right, excellent. Thank you very much. I think I switched. Oh, perfect. Oh, I think we're backwards, but that's okay. That's going to get forgotten. So this one is mine. That's yours. Yeah. Okay. But this is the one that's hooked up to the computer. Oh no, this is UW. Yeah. So one of them. Anyways, okay, we're perfect. We're good. Perfect. All right. All right, everyone, hello. We'll go ahead and get started. So thank you very much for coming today. This is annually a very exciting day for our students and for me and for our school, as this is our 6th annual Applied Project Showcase, which really is kind of our capstone day for a year's worth of very dedicated and very intensive work by our MSBA students. All right, we're working out some audio stuff real quick. Thank you. All right, so great. Thank you everyone for attending, both here in person and those that are watching in our live stream via YouTube. And just real quickly, before we begin with our first presentation, I'd like to go over some details, give you an introduction, a little bit of the journey that our students have been on, both through the academic program, through in receiving and earning their Master's of Science in Business Analytics here at UW Tacoma, and also a little bit about the Applied Project program to give you some context and also discuss a little bit about our sponsors for this year. Okay, so for our agenda, also real quick, we will be having our presentations, and they will be live streamed from 9 a.m. to 12:30 p.m. We have 11 project teams, well, technically 12, adding our Analytics Innovation Club, where they'll also be talking about 2 community-based projects that they were able to deliver value on this year. We will be taking breaks, so we will not be going consecutively. We have a very tight time window today, which is why I'm going to make this quick, and we will also have on the hour, we will have 5-minute breaks. We will have a lunch break from 12:30 to 2 p.m., and then we'll have our live poster session. This will not be on the live stream, but from 2 to 3 p.m., we invite you to come here to Milgard Hall, room MLG 110, and have a chance to actually interact directly with our student teams and view their posters, highlighting their work. A little bit about the program. It's a STEM hybrid work-compatible program. So in addition to going through the curriculum and consulting with our applied project sponsor organizations, many of our students have careers that they're continuing and they're working full-time, which can be I think it's safe to say maybe that's challenging. Maybe that was a challenging task, right, to go through. So again, kudos to all of you for that. It is a full-time program. Just here's a little bit of context of some of the courses, not all of them, that are offered in terms of the training and the skill building that our analytics students go through in the program. And in addition to our courses, we have our year-long experiential learning component, which is our applied project, which is really what we're highlighting here today. So a little bit about the applied project course. So our student teams that you will be viewing, seeing their work today, have been paired with an organization for an entire year, yes, from June to June, working on a business problem using the organization's real data to derive a data-driven insight or insights, and also to deploy a solution that has been derived from those insights that they've discovered over the past year. So it's done in 4 phases. Phase 1 dedicated to understanding strictly the business and the industry before we even touch the organization's data, which occurs in summer quarter. Phase 2 in autumn quarter is really the descriptive and diagnostic analytics, but also the data discovery phase, where our student teams receive for the first time and have a chance to get down and in with their organization's data and create some visualizations, try to draw insights from that. Phase 3 in the winter quarter is when the teams have started to create the data models, adding the predictive analytics component and also prescriptive to identify solutions. And deployment occurred this quarter in spring, in which you'll be seeing some of their deployed models via the live demonstration component. I would also real quickly, I can't do justice enough the thanks that I want to give our applied project sponsors this year for all of their time and all of their guidance for our students and helping them along in this journey and for their contributions as a result to our program. Virginia Mason Franciscan Health, Hikido, Multicare Health System, PropertyScout.io, Schnitzer Steel, Sound Credit Union, South Sound Military and Communities Partnership, Tacoma Power, University of Washington, Tacoma, and Westwood Shipping Line. So again, thank you so much. All right, and we will begin. I would like to invite Team 1.
Okay. Hello, everyone. So we are Team 1. I'm Swapnil, and here are my team members, Radha, Jean, Ryan, and Will. So our client is Common Spirit, and it's part of Virginia Mason Franciscan Health. So let's talk about Common Spirit a bit. So this was formed in 2019 with combination of CHI and Dignity Health. They are spread across 21 different states. They have 1,000+ care sites and approximately 140 hospitals. They are nation's leading provider for Medicare and Medicaid services. What is Medicare? Medicare is an insurance program for elderly people who are aged above 65 years and also for disabled people. So what are we doing here? We found out that US spends per capita on healthcare a lot more than other developed countries. Medicare in US provides coverage for approximately 65 million people, which is nearly 20% of the US population. In this situation, the accountable care organizations strive to achieve the savings to the efficient care, through efficient care delivery and the coordination. So we, the UW MSBA team, we want to leverage data analytics to support VMFH going efforts in reducing cost and optimize the care delivery for the 50,000+ Medicare population. So what is our project goal? Our project goal is to develop a complete analytic solution to help our leadership and key stakeholders of VMFH to make data-driven decisions that reduce the patient out-of-pocket expense, increase their patient health outcomes, and better the societies that they serve. During this journey, we got the opportunity to work on multiple tools. Starting right from Excel, we utilized it for data cleaning, moving on to the SQL server, where we created databases, tables, views, used it for ETL operations, moving on to visualization tools like Power BI and Tableau, where we used to analyze our data set, and then we created measures, calculated fields, and a lot of those stuffs. Moving on, we also worked on R and Python, where we developed our models. For example, random forest model, Bayesian ridge, logistic regressions, etc. Coming to the high-level architecture, what you see here, we got our information in the source system, which is then integrated, then moves on to the data stores. Then we utilize it to analyze the data using BI tools, and then it is communicated in form of the information delivery. Few of the business questions which we asked ourselves was, first, how can we leverage this analytics data to identify the specific cost drivers for using the available input variables which is given to us? The concern was when we are utilizing these cost drivers, it should not be impacting the patient health outcome in any way, or we should actually be able to improve the quality of care. So the next question was, what will the impact of our model be? Whatever we have done, whether it be the outlier identification of high-risk patient or whether it be the cost reduction, how will it address and alleviate the financial strains caused by rising operating expense and lead to improved financial stability for Virginia Mason? Next, Ryan will take over from here.
Thank you, Swapnil. So to best demonstrate our data analytics solution for Virginia Mason, I really wanted to cover our data pipeline. I think that's where the most value for this organization is going to be delivered, independent of our results in this project, right? Apologize. Well, how is that? Well, the data first is started in disparate systems within their data warehouse. It is gathered together in a sandbox-like environment for this MSSP research. And then we extracted that to our UDIB virtual machines. This step will be admitted in the final deliverable, but it really created more of a safe environment so where we didn't disrupt their operating systems. And that's where we did our data analysis. We took the time to identify, well, how are we going to solve this problem of reducing expenses? Well, we identified a couple of labels. One of them is a classification model that's used to detect rising risk patients, and the other one is to predict their expenditures based off of their health data. This is given to a Python script or two different models. And it generates an output once yearly to the stakeholders at Virginia Mason. Again, this is independent of our results. This report really can provide a lot of value and insights as far as machine learning capabilities in the healthcare sector, as well as analysis of patient-level analytics. So our two models here, both final models were random forests. As you can see, we tried quite a few different ones. And the outcome variables in here were classification as binary, outlier, non-outlier. And the other one was a expenditure prediction, so we're trying to predict how much they're going to cost. And through these labels, we can also look deeper into other things such as their coefficients and other information and insights into behaviors and patterns of patients. And here's just a general script of an XGBoost model that's used cross-validation and tuning of hyperparameters. And I'll pass it over to Will.
So here we have another example of the Python script, but this time for the price regression of predicting next year's patients. And what would go into here is your list of regressions you want to try, and then also all the data and whatnot. But here we have the R-squared scores for non-outliers. So we had an accuracy percent of 47.2, which was pretty good after all the transformations. And we had to transform the price variable as well to get even close to this number. The outliers, we also had a R-squared score for the test of 45.2%, which is way ahead of where we were last quarter at least. Next, we have a plot of the standardized residuals from this, and then on the right, we have the examples of what would be fed back into the client's database. So over here, the second to the last column there has the predicted costs. And as you can see, the top is non-outliers, and the bottom is the actual outliers, so you can have a really good clue of the difference in cost between them, which is pretty clearly significant. As you can see, most of them are in the like $2,000 range or so, and for the outliers, it's in about $40,000, give or take. And with that, we're going back to Swapnil.
Thank you, Will. So finally, using this model, what are the type of decisions that we can make? The first one is, this will allow Virginia Mason to have the data-backed information to negotiate with their peers. The second one, and the most important one, using this sample, they can actually replicate the same for their entire population health and also predict the high at-risk patients. So few of our findings. with respect to the data which we were provided. There were 3 different types of data: the claims data, the population level data, and some amount of patient level data. We found that while the high at-risk patients can be identified using the claims data alone, there are various external factors which were not accounted for the influence on the health of the patient year on year. And the precision of predicting the patient-level expense using claim data is limited. Population-level expense prediction has better results. Hence, from different data types, we were able to derive different types of conclusions. So what are our recommendations on basis of this? Instead of using the claims data and population data alone, why don't we use the electronic health record data, which could provide more knowledge at the patient level? And it would result in better prediction of both high at-risk patient as well as the expense prediction. Use of text data is strongly recommended. Why is that? Because we observed that when we did we used cloud generator to have our text, we found that there were various sentiments which were not available with the numerical data available to provide the focus on the required variables that can help us predict better outcomes. Few of the environmental factors, while it may prove that the predictions at the patient level are unsatisfactory for business rates, but population-level statistics and modeling will provide to be more useful. Because environmental factors using claims data and just patient-level data is not possible. We need to include the population-level data for this purpose. What are the potential impacts? Firstly, it is going to add value to their financial capabilities while increasing their ability to compete in this market, because the rising operating expense is causing a problem in the healthcare sector, and the way to reduce is to cut down on their operating costs. The second one, it will help us strategize on the profitability and analytical capabilities of value-based agreements between Virginia Mason, its payers, and it will help them negotiate better for their financial benefits. Hence, through this project, we have tried to provide Virginia Mason the required information to make the best decision for themselves. Thank you so much. We'll take your questions.
Any questions? Love to see it. Thank you, guys.
Thank you very much.
Thank you.
All right, if we could now have Project Team 2.
Good morning and welcome, respected faculty, friends, and family to the Applied Project season finale. Sorry, what did I do? Yeah. So we are Team 2, and we worked with Virginia Mason Franciscan Health on the project developing population-level risk stratification models, which would ultimately help them to reduce cost and improve patient outcomes. So the objective of this project initially, of course, like any other project, is to identify features that really impact the kind of value that you are trying to predict. So that's what we did, and we used the features that we got, we funneled down the features, and we used these to create a risk stratification model to predict the risk score of the ACO patient population. Now, why this risk score is important is because it's a widely used tool by the institutions to predict healthcare expenditures, as well as to measure the quality of care provided by the institution. The data provided to us was complex, exhaustive, changed hands, was more than 170 variables, but I would like to invite Kristen to help you out, walk you through the steps of the magic that she created to develop this model. So, Kristen, please.
Hello. So we started with data which was patient demographic utilization and diagnostic data. We combined all of those into a set of data that can be looked at compared to both the CMS, which is Center of Medicare and Medicaid Studies risk score, as well as an internally calculated risk score that favors utilization within Virginia Mason Franciscan Health. We compared this data through diagnostic and descriptive analysis to find features that not only correlated to risk score, but also might tell us something about the populations within each risk score group. After modeling different approaches, we realized that the complexity of the risk score was hard to calculate with any precision due to its structure, its specialization by individual patient, and the complexity of the variables, which led us to approach this by looking at what are we actually trying to do when we were talking about risk score stratification. We're trying to identify population groups that tell us something about those patients and their needs within the healthcare environment. In order to do this, we focused on a multinomial logistic regression and classification model, which allowed us to take the total of all the risk score populations, normalize them, and group them into 4 individual classification groups: low, low intermediate, intermediate high, and high risk scores. Predicting risk score tier provides more operational value than an individual risk score. It doesn't matter if the patient has a 1.4 versus a 1.6, that is a high-risk patient, and they need care equivalent to a high-risk patient. It supports continued clustering of the patient population for other analysis and grouping within ACO structures. The other division we did was look at new patients versus continuing patients. The rationale for this is new patients, we have the least amount of data, both demographic, diagnostic, and utilization data, because they are new to the accountable care organization. When we started with the new patients, we found that we have great performance with multinomial classification in the lowest category and the highest category. But the middle tiers, which are the most informative for business and operational use cases, were the hardest to identify. The reason they were the hardest to identify is someone in a population 2 will demographically look like someone in population 1, but their utilization diagnostic criteria is what defines them as a category 2. Same happens with category 3, that without diagnostic and complete demographic information, it is hard to classify them. But we can still say with fair success who is at risk for being a high-risk patient and who's at risk for being a lower-risk patient. The other thing that this provided was feature weights. What is actually the features that tell us that this is a high or low risk score patient? And the primary ones that were the most interesting is our low, intermediate low risk score were older patients for the Medicare ACO. They were 70 to 79 years old. They are new to the ACO, so new to this organization, but they are not present in the majority of specialty codes or diagnostic codes, and they have lower utilization compared with the intermediate high risk score, which have a similar distribution to our highest risk score, and also are part of similar specialty codes. Continuing patients provided a lot more information. We now have diagnostic and utilization code for not just 1, but multiple years. When we applied this model to this group, we got much better scoring. We can see who performs as a low risk to a high risk patient. And we can also see those who are at risk of possibly being in a high risk score group from an intermediate high risk score group based on their utilization to date. Because the primary things that we see between intermediate high and high risk score is how they utilize inpatient and outpatient services. However, with continuing patients, what we see is that there are a lot more aspects to their identification. They are overall older population. They've been with ACO for a while. They have specific diagnostic codes which are coded to protect patient identity. And certain codes have higher prevalence in one group over the other. What was most surprising in all of this analysis is it's not the oldest population that are the highest risk. It is actually traditionally younger populations that start showing up in the higher risk category. The other predictive value is one we would assume that there's a direct relationship for, and that is their entering risk score at the beginning of the patient year and at the close of the patient year. But this changes. New patients has a pretty standard correlation. If they come in at a 4, they're most likely to be a 4. However, continuing patients after 1 year in the ACO, if they come in at a 4, they're still a 4 after their first year, they're likely to remain in the highest risk category, which means that their diagnostic and utilization is probably going to be persistent throughout the population. How we're trying to operationalize this for the Virginia Mason Franciscan Health is dashboards looking at individuals who are being predicted at high risk and what their utilization looks like and what diagnostic codes that they're in, because this puts burden on the healthcare system as these patients have to be seen by specialists. They also spend more for that care and utilization. So providing a list of patients who are at risk for high risk score or from an intermediate to intermediate high group going into a high or intermediate high group will help them identify patients for early intervention. And for new patients, one of the things that we are missing in order to identify what risk score category we can predict them to be in is missing data. Missing data we have from patients or patients can provide at the beginning. So the other recommendation we have is reach out to patients where we're missing diagnostic scores or demographic data in order to help inform our model. And with that, I hand off to Ashleisha for findings.
Thank you, Kristen. So the summary of the findings can be easily bifurcated into 3 sections. The first we saw was the category of the patients that fall into it depending upon their risk score and utilization. For category 1, we see that the patient population is of the younger age. There is low, high-risk diagnosis for this population, which ultimately translates into lower utilization of resources from the ACO. Category 2 shows some missing demographic data, which makes it a little tricky to work with and brings down the accuracy when we work with this category of patients, where we saw, as already mentioned by Kristen, that the patient population is aged from 70 to 79 years, and it somewhat behaves and aligns itself with category 3, which is the most complex category to work with when you are working in this entire project. And again, it shows a lot of similarities with category 2 patient, again with category 4, so it's kind of a confusing area to work with. And there is a lot of variability in this category also, again, due to owing the missing data that we have, which again brings down the accuracy of the model when predicting this category. Category 4, we saw the model works beautifully. The only variables that stood out while working with these patients was the provider specialty and the diagnosis coding. The second set of findings is related to the feature importance, where we saw that the patient pool has been divided into existing patients and new patients. And for both these pools, we saw that previous year risk score and age, these two are very important factors when it comes to the patient risk score. It's contributing as well as a predicting factor. Again, apart from that, provider specialty and diagnostic codings are important features. The final and the third set of summary findings is related to the population. I think this section is more like of recommendation. We would say that for new patients, like Kristen mentioned, reach out, get the data as soon as possible and as much as possible at the start of the benefit year so that at least there is a number to work with and then which can be improved along the year when you get more and more data from these patients. Then, of course, category 3 is a Bermuda Triangle. It is complex but insightful. And I think with the use of more sophisticated tools and techniques, if we explore this category more, this is a whole project in itself for the next year. But it's a really insightful category. And if we get into this, it will give a lot of insights beneficial for the ACO functioning as well. And last but not the least, apart from all the other features that we talked about, we also found that outpatient versus inpatient encounters and unplanned readmissions, these two variables also contribute in a very big way towards the high-risk score of a patient. And these are the bunch of articles we referred to. If you found this project interesting and you want to know more about it, please do go and refer them. They're really insightful. And before we bring this project to an end, or this presentation to an end, we would like to thank our sponsors at Virginia Mason Franciscan Health for giving us this very interesting project, because I think we used almost every concept taught in classroom on this project. We left no stone unturned. And last but not the least, thank you, the amazing faculty. And Oske for all her all her support. She's been very supportive and patient with us. And yeah, so that's all. And before the floor is open for questions. Thank you so much.
All right, if we could have Project Team 3 to the podium.
I don't like it like this. I don't know why it's doing this. Oh. It's not on.
It's not on there. 1 second. Oh my God, it's not.
Just make sure for him. Okay. I think you're good.
Okay, thank you.
This for the slides.
Thank you. Hello, everyone. So we are Hikido, and this is our team, myself, Kajal, Cameron, Vinodini, Aiken, and Sneha. So little bit our goal is to build like a personalized recommendation system for the Hikido app. Basically, they are addressing the mental, social, and emotional healthcare well-being for the kids. Mostly the users are parents here for the app. And we welcome the UW panel, and we thank you for the constant support. Then regarding the Hikido background, it is a 3-year-old startup company, and they recently started a Hikido app since last year. And our team is here to do all the analysis and build a recommendation system, which will send the relevant materials to the app, so that every day the parents can go through the materials and help in the pattern tracking for the kids. So we worked in 4 phases. We actually followed the CRISP DM, all 6 stages clubbed into the 4 phases. So these are the major 4 deliverables. The first one is actual model recommendation system, which we built for the Hikido. The second is cognitive analytics, that is the additional Tell Us Kiddo Power app for the users. Third, Power BI, and a lot of dashboards from Power BI and the Tableau and the documents. So this is like more like a business solution architecture. Our data goes into the MongoDB. From there, it will go to the recommendation system, which we built, and they are using Microsoft Azure Cloud. From there, it will go all the reportings and the dashboard to the Tableau and the Power BI. And then finally, all the predictions will go to the app and their systems. So the first work which we deliver to the Hikido is we actually define their feedback mechanism. We actually build their app. The first we built their feedback is by putting a dislike and like button, like Amazon system, on each app material, so that we know what they are liking or disliking, and based on that data, we build the prediction if they will like in the future or not. So this was missing, so we built first this one in the phase 1. Second, based on that, so the app is releasing in alpha, beta, and gamma stage. So we crossed the beta stage. So based on the test data, we have created this dashboard so we know what user is liking which competencies. You can see we have 5 competencies, and they are divided into 20 sub-competencies, and each sub-competencies is divided into materials like blogs, activities, or ask your kiddo questions, all those small activities on the app. So this is the additional Tell Us Kiddo Power App where they can share their feedback to us. And this is our road for model testing. Before beta testing, we did not have much data, so we had a test data. We used Azure ML Studio and RStudio, and we did a lot of regression testing, and we got accuracy like 97% because that was randomized data. But finally, after beta testing, we are more public in the gamma phase. Now we have a lot of data, so we have finalized our model in Python, which is KNN. With K means we used K-fold technique for splitting our data, and our accuracy is 88%, which is more better than like last test data. This is the dendrogram which we created to learn the 2 clusters which has more similar points. And these are the steps which Cameron will go in deep about the demo.
Okay. So to start things off, we created 3 models with them, all in Python. The first model, all 3 models use KNN with means because that's a version of KNN that's best suited for sparse data. We also use a surprise package, which is a variation of scikit-learn, which is specifically designed for collaborative filtering. So the first model we built is for resource ID. This is the actual resource itself. We had an accuracy of 97.5%. One thing I want to note is we had a really hard time predicting when a user wasn't going to like a piece of content, and that was because our data set was imbalanced. So what we did is we oversampled, and we got a lot higher stability in our models going forward. So this is the most granular prediction we have. Our other model focuses on content type, which is like activity, discussion, drawing, whatever it is, right? And then here we had an accuracy of 85.5%. Our third model is competency type, which is almost like subject, right? Which had an accuracy of 85%. One thing that's really important I want to note, we're able to rationalize our performance going down with the increase in granularity or decrease in granularity, because think about this. If you like action movies, that doesn't mean you like every single action movie you've ever seen before. So I suspect as we get more data, these 2 models, which are less granular, will perform at a worse and worse level until it kind of levels out. And right here is just a little, this is kind of the path we took, which Kajal just explained. So let's go into the actual system. So we did our model training in Google Colab, but then we moved everything to VS Code so we could actually interface with the SQL server that's on this computer. UW SQL Server works, but the issue is the 2-factor authentication makes it difficult to actually query using Python. So we use VS Code with the SQL Server on this laptop. So to start things off, we're first pulling all the data, which represents all the data that was collected for user feedback, right? So this might be run every day or 2, or maybe it will be run multiple times a day. Once we have that data, we do some general data preparation and then run that data through our pre-trained models, which were trained in Google Colab, and the hyperparameters were tuned to then make predictions. So over here, we're making predictions on every type of content we're predicting. So for every user, we're using a nested loop to go through and predict if they're going to like a piece of content or not. It's essentially how it works. So as we move along, right, we get to a place where now we can take that data and insert it into our prediction table. Every time we do that, it's actually going to clear everything that was once inside that table, so we have the most up-to-date predictions as possible. At this point, we are then going to query that prediction table to get the data, which will actually be used on the platform to make our predictions. So as we go on here, we built a conditional, kind of like this is really just simulating how this would look like on Hikido's platform. Realistically, you won't have these conditional statements that are displaying pieces of content based on what they like or dislike. You will actually just have it display the content itself. But for demonstration purposes, this is what we're using. So I can show you how this works. So let's say I'm user 1. Sorry, let me scroll down here. I can say, okay, I'm user 1, that's what it's ID'd me as, and it will recommend them 2 pieces of content. So we combined the 2 less granular models together to form a single prediction. The reason is if you only have 5 competencies, right, you're just gonna end up cycling through them every single day. So to make it more unique, we combined competency and resource type together to form a more unique pathway for users to explore. And then of course we have the actual content type or the content ID, which is being recommended. And I can show you how this changes too, right? I only have 5 pictures in here, which were provided by Hikido. And by the way, this is heavily representative of what their content looks like. But as you can see, as I switch to user 2, our content ID recommendation changes to content ID 1. So that's just kind of a background on the system we built. As far as recommendations go, going forward, I think it's important, oh, I don't know why I did that. I think it's important that Hikido tries to maximize the amount of feedback they're actually collecting for their users. And I think to do that, they're gonna have to perform A/B testing. So while we actually designed the UI and the functionality of the current feedback mechanism, I'm not gonna sit here and say it's perfect, right? It could be the best, but I think it's important for them to try other options. Maybe they use a stars-based system, right? Maybe they move it to a different location. Whatever they need to do to maximize the amount of feedback they can collect from their users, they really need to engage on that activity. Another thing is, while we have trained the model and it's functional, it's important to realize there's only 30 users who are actually testing the platform right now in the closed beta. Our data only spans 1 month, and for a collaborative filter, that's really nothing, honestly. So realistically, they're gonna have to retrain this model once they collect more data because things could change, right? Another aspect that they need to think about is performance. KNN is not the most performance-friendly model in existence, right? So once they have more data, it might be worthwhile switching to a different algorithm, such as support vector machines, or really anything else that meets their performance expectations for both the server-side impact as well as the actual quality of the predictions it's giving to the users. So I'm now gonna pass it back to Kajal.
Yeah, regarding the issue and concern, it's just we don't have historical data, but we are trying with the beta testing and gamma testing data. Assumption is something that the more the best feedback mechanism, the feedback data, the more the accuracy and the recommendation will work, and it will be working in the future. The next step is just the closing of the project, and we'll hand over all the deliverables and prototype to them. Thank you. Any questions?
Thank you.
Take it back.
Hey, how's it going? Good, how you doing? Okay. You guys are ready? Just make sure you stand in front of the mic. Okay. On the other side. Where's the clicker? Does this work? You'll have to plug in a USB if you want to do that. Oh, okay. I can do it here. I'll just do it with that. Just make sure it's on. Test it real quick. I would just go with your arrow. Yeah. Okay.
morning, everyone. Thank you all for being here. We're Team 4. We've been working with multi-care OCED departments for the past year. We have here our team of consultants. Oops, sorry. We have our team of consultants. We have Kara, Michael, myself, Christopher, Nana, and Ga. Next slide, please. So to start off with our table of contents, what we're going to cover during this presentation. So we have our project overview and objectives. We're going to go over the problem and how we tackle that issue. Applied project accomplishments, what we have done throughout the year, 4 phases, then machine learning model, live demo of Power BI and our Power App, and then we have at the end issues, concerns, and recommendations. So to start off with our project overview, so our first business problem will be how can nursing performance be measured with data? So which data is necessary, how can we obtain that data, and how can that be useful for the nurses for them to improve their performance? Once we know which metrics are necessary, how can we create a dashboard to increase their engagement and their performance? So our goal and objectives, so utilizing Power BI as our tool to create our dashboard, we analyze and patient satisfaction as well as performance for the nurses. We also use machine learning to determine which variables and data pills were necessary and were make a difference, were significant to the discharge LOS. That's where we were most focused on when doing our recommendations. Next. Now I will pass it on to Nana. She will go over our 4 phases.
So I would like to briefly discuss about what we have done during this year-long project. So for phase 1, we meet our client to have an understanding of their current business problem, and then we conducted in-depth industry, market, and company analysis to gain deeper understanding and to define our project goal and project scope. Moving on to phase 2, we received our data and we performed data cleaning, and from there we started building our Power BI dashboard. For each of the phases, we've been making sure that we documented our findings and to present to our client and gain their feedback. For phase 3, we received our new data for the winter period and we updated that into the dashboard. We also performed a white paper research, which is also as requested by our client. At the same time, we started building our prediction model by Azure Machine Learning. Finally, for phase 4, we finalized off our previous development, and we also came up with a Power BI solution, Power App solution. So for machine learning model, our decision variable is the discharge length of stay, which is the time between a patient's admittance and discharge. Here are some of the potential variables in our data set. The reason that we are predicting this length of stay for our clients is that it can help them to find opportunity to better managing the patient flow and at the same time reduce the waiting times for other patients. It can also help them better manage nursing shifts and use the resource more efficiently. So before we ran all these algorithms, we actually conducted a few studies in the R. For example, the correlation analysis and the statistical importance analysis, and then to find our final variables. And then we ran all these different algorithms, and boosted decision tree regression appears to be our best model because it appears to have the best performance, and as it has the best goodness of fitness for 46.97%, and as well as the lowest errors. So finally, for the deployment stage, we created this very simple and easy to use length of stay calculator. So basically just type in the values or select from the drop-down box for the independent variables, and it will automatically calculate the length of stay. Next, I'm gonna hand it over back to Chris for the live demo.
All right, so now I'll be covering our live demo with Power BI dashboard. So we're starting off right here, we have our arrival time by patient volume. So as we can see, there's 2 dotted lines. One is with the medium patients and the other one's with the maximum. We can see the tooltip that it shows the arrival time and what was the patient count for that specific time. So as we can see at 8:56, for the data that we have available, a total of 33 patients came in during that time. Moving forward, we have our average LOS by time period. So as we can see, October was one of the lowest months, and then it increased all the way up to in November of 2022. This is live data, so it's really helpful for our client and multi-care to know which time of the year patients are coming in more frequently than others so that they can staff better and maintain their discharge LOS in a standard time. We can also see on the tooltip the minutes of the average discharge LOS did go up as the patient's count and volume went up as well. So for multi-care, it's beneficial for them to do the proper staffing and have the right equipment during those time of the year. Moving forward, we have our patient volume by month. So you can see each month with a more accurate view of the number. So you can see that difference between October and November was about 3,000 patients difference. Going to our bottom part, we have a shift complaint by volume. So this is essential to provide what was the most common cause patients walked into the ER, right? So as we can see, abdominal pain and cough are the most common one, with a little bit over 10,000 for abdominal pain and a little bit over 7,000 for cough. So for multi-care, it's beneficial, right? So that they can have the right equipment, right nurses, and everything necessary to treat all the shift complaints, as these are the most common ones. Moving forward, we also have our average arrival triage by attending level. So as the patients come in, depending on the care that they need, they get classified in 5 different categories. These different categories go from immediate 1, which means the patients need be taken care of right away, to non-urgent 5, which is that they can wait in the wait room for a little longer. As we can see, immediate 1, as they need care right away, they take around 8 minutes to take care of those patients. It's all here provided in the bottom. So, and then moving forward to our total discharge by Hikido level, it's provided for the 5 categories that patients get classified on, so the multi-care can have a look of how many patients came in for a specific month under that specific category, right? So you can see the tooltip, it provides by year and by month. This is live data we have all the way till April of 23, so we have shared this with our client for better recommendations and solutions. Now I'll pass it on to Michael. He will go over our Power App solution.
All right, so for our cognitive analytics phase, our team developed a mobile application which field staff can view their own KPI benchmarks through their company devices. A quick disclaimer, we're using our own name so that we do not want to reveal the identities of the nurses to the public. So let's just say in a scenario, if I'm a nurse and I want to see my own KPI data, I can load up the app and it's the first screen I'll see. So from the main menu page, I have the option to either select my name, select my colleague's name, or I can search my name up. For this demonstration, I'm just gonna search my name up, select my name, and it should lead me to a data table. So right now it's empty because currently nothing has been empty yet, so I can interact with the date filters. And let's just say I want to see my performance on May 7th, and choose at the end of the week, and it should reveal the relevant data I needed. So from there, I can see how many total patients I treated for the specific day, how many shifts I covered, the average acuity level, and the average length of stay. So in practical uses, the field staff can utilize our mobile app so that they can keep track of their own historical performance, both at an individual level and with their colleagues. And also it benefits on our clients, so that because they grant that data transparency both between upper management and the ER on the field. So that will conclude our live demo, and let's move on to our closing remarks. All right, okay. All right, so part of our issues and concerns that we have to comply with HIPAA regulations, but there's a good data privacy reasoning behind it. What that means is that we do not have access to patient demographic, their age, or any type of personal information. Second is that we do not have any nursing reports, and that could actually benefit our project immensely because it will give us a better context into why these patients are staying in the ER room for a very long time. And recently, we took a text mining course that have actually enhanced our analysis. So part of our assumption is that our analysis are based on what our data are given to us. Any type of public industry information, such as news article, any academic research paper, and any authorized internal sources from our clients. So as a team, we want to come up with a few general recommendations to our clients. First is to utilize our decision-making Power BI dashboard to analyze seasonality trends, patient volumes, and allocating the right resources to the busier months. Second is to investigate through night shifts to discover any practical correlations with patient length of stay according to a machine learning model. Lastly is to implement an internal mobile application for the field staff so that they can be more engaged with their performance. So that will conclude our presentation. On behalf of the team, thank you so much for listening to our showcase. And for those of you who are watching, hope you learned something from us. So any questions for the team?
All right, thank you, team. Okay, we will go ahead and take a 5-minute break, and we will resume at 10:05. Please feel free, there is coffee and tea and bagels in the back of the room. We'll resume shortly.
You up next?
All right, everyone, we'll go ahead and resume. And I would like to introduce Project Team 5 to introduce themselves.
Thank you, Michael. Thank you, Michael. Good morning and hello, everybody. So we are the Project Team 5, and we are presenting for our client, Property Scout IO. The agenda for today's presentation is I would be walking through the team introduction, project overview and timeline, and the data flow diagram. And then Hannah would take over from me, and she would go over the descriptive model and the dashboard demo and some limitations, concerns, and recommendations. Moving on. So we are the team, three of us, Hannah, me, and Sushmita, and our client team, Property Scout, it's Caleb and Mariana, the founder and co-owner, respectively. A brief company overview of Property Scout. So Property Scout was founded in 2019, and it works on a business-to-business platform. They offer services, quick and hassle-free services like several real estate documentations like liens, deed, or mortgage, which otherwise would take several weeks to get through different counties. Other than that, they also do have complete comprehensive property documentations like previous and current owners, recorded mortgage, extensive structure, amenities, and external building information. So in all, very comprehensive real estate database company. So the issues that they have, or as I can say, is the project question or research question that we have is the high customer churn rate, which is approximately about 20% per month. And the goals for our project is to identify the factors which influence the length of customer subscription and create an interactive dashboard in Power BI for them. The project timeline is split into 4 different quarters. Throughout the last year, all of us did actually. And the first quarter was to understand their business, the client, their market, and completely understand thoroughly the question or the subject question that we had. Then we moved on to second quarter, which was the beginning of ETL, extract, transformation, and load of data, and understanding the data that we received from the client. In the third quarter, we started with our initial data modeling and dashboard development, and then we are now in the final quarter of our course, where we are finalizing all the deliverables to the client and deploying the solution, and the final presentation, which is today. The next thing that I would like to walk through is the high-level system architecture. That is how the complete business would function for our client. The customer activity, which are recorded by Property Scout, and the Stripe partner, which is another platform, external platform, where the payment-related information of the customers are maintained. And this 2 data from the Property Scout and from the Stripe would go to the ETL, from where we did our data modeling and developed our Power BI dashboard for the client. And moving on, I would like to hand it over to Hannah for the descriptive part. Thank you.
Thank you, Jayanti. Descriptive model. So you're probably looking at it thinking, hey, we did so many predictive models. Why is it descriptive? I will, before I show you the model and before I show you what we actually learned from that, let me move on to some limitations. Let me run you through that. It will make more sense why this is the approach that we took. So Property Scout really is majorly 2 things. It's many things, but 2 very main things, which is a startup that started in 2019, and it's a startup in a real estate data space. So I hope not, if there's a person in here that didn't pay attention to real estate markets since 2019, congratulations, you're probably a unicorn, but we all know it's been extremely unusual. There's been a lot of crazy market situations, house prices just skyrocketed, people, had bidding wars, there's just a lot going on. And this is the data that we're working with. So generalizing that data is extremely hard because this is technically not what it used to look like. You know, let's say look back 20 years. Okay, look back from 2019 on, okay, because 2008 is not a good example either. However, you see what I'm getting at in here. So that's one thing. Second thing, the startup part. So startups are very dynamic, right? There's really not that much politics going on. So what they do is they learn and they implement. And they learn about one thing, it's a great idea, they go and change it, and that happens in weeks. In bigger companies, it's months, if not years, to make a change like that. Hence why the data that we were working with was really developing from the moment we start. There were changes that were applied after we started that turned out to be very beneficial for what we're trying to find out. Last but not least, we did not have access to any external information on the clients. So this project for us really focused on who are the clients, who needs this information. Jayanti went into a little bit the data offering. So for instance, it's not as straightforward for me to understand what do you use Property Scout for? Why not Redfin, right? What's the difference? The difference is like you go to Redfin when you buy a house, but Redfin is not gonna give you mortgage information, it's not gonna give you liens or deeds, it's not gonna give you this very in-depth kind of stuff that you usually get through a county. So I, for instance, wouldn't be able to tell you from the top of my head last year who needs this information. Because of all this, we've decided that, well, yeah, we could create a predictive model, but how is it going to be useful to predict based on something that's already in your database? Like, we can't predict a user, which users are going to stay longer, if we don't have any outside information on them to determine whether it's even worth approaching them, with this offer. If the only information we have is what is he doing on the site. Descriptive model, essentially. We went with linear regression, which was the most friendly approach to the data that we had. We had to get a little bit more creative also about what is it that we're actually going to put in this regression, what are we going to measure, and the main approach in here is to really pinpoint further research for our client. Where is it that they should be looking at? So R squared 0.54, this is kind of the conclusion of what I was just talking about. This is the reasons, I guess, and that's what we've got. However, we can get some good insights from this. So for instance, total search count, which they measure essentially each searches that you do, negatively correlates to the subscription length overall. That doesn't really sound like it should be the case, but this is kind of what we arrived at. And another thing is 3-day pass. These are the two that I would like to highlight. 3-day pass is the subscription that they offer as an intro. You just pay like $10. You have 100 searches. You go and you see if this is what you're looking for. It looks like that also doesn't really work very well for customer retention. Based on all of this and customer feedback, what we aimed at is create a dashboard for them that they can measure those things and they can draw further insights to add to their platform and add to the information that they're receiving. So let me show you what it looks like. All right, so Property Scout has two freeform questions, two areas for freeform questions. One is post-purchase questions. And that's essentially whenever somebody buys a subscription, they give feedback. Once again, that was implemented last year, so there's a limited amount of information. It was standardized at some point as well, which is why we're able now to look, okay, people in insurance area, what kind of feedback are they giving, right? Same with investigations. What kind of feedback is there? Some of them are busier than the others. Once again, still work in progress in here, but it's a good start, right? Obviously, property comes up, but investigations look for title, right? Look for ownership, for deeds. Like this is kind of the information that they're search after. Another part is cancel reasons. So anytime they cancel, there's also a freeform question that we're trying to, work with in here. They standardize it into there's 2 questions, 2 types, I guess. Okay, sorry, this is not really, okay. So you've got 2 questions. You could not find property data, and there's inaccurate property data. And we can slice on that as well. See inaccurate property data, information, deeds, liens, are they outdated, right? So this is a question of quality of data that Property Scout is providing. And then once again, we've got search area as well in here, so we could see from particular search area, which is what we think are the industries that are using the platform, right? What kind of feedback are they giving? Next, what we did is just really your signals dashboard. So you've got your KPIs on the left side in here. So active subscribers in the past 30 days, new subscriptions. I mean, it is pretty straightforward, but it gives you a bit of an insight into what's happening on your site. So who is your top active customer, right? How many searches do they do? And that just brings that question, who's this guy? Who's Dan Goldsmith? Who is he representing? What is he looking for, and how is he using this information? Customer segments breakdown, that's also something that our customer really wants to look into further. So, you know, we could click on that, and then it will show us who are the legal customers in here? Who are the lending customers in here, right? So just little knickknacks, but that they really are helpful for our customer to understand overall their market and you know, their customers. Also, subscription type per month. And one thing to note in here, 3-day plan is this on the bottom out here. So remember how I mentioned before that, you know, it's negatively correlated to subscription length, but it is a big chunk of what you're getting every month. So that also begs a question. Okay, you get rid of 3-day pass, but are these customers going to sign up anyway and go with a more expensive plan? And the more expensive plan, this is really $10 versus $50. So is getting rid of this plan really going to make sense from financial perspective, because you are going to lose this revenue from these people? So, you know, these are questions that we're baffling with. Another part, activity dashboard, and this just really gives you more insight into what people are looking for. So, for instance, for search states, right? California, no surprise, we knew it from the get-go. This is the very hot market in there. What we didn't know, for instance, is, let's say, your top customers. Who is Dan looking for? Where is he making his searches? Pennsylvania. Why, right? What's in Pennsylvania? Is it a booming market? Like, what's going on out there? And the other way around, right? You can just see, like, who's searching California the most? You know, it's just going to give you all those answers in here. So we're hoping that this is going to be a good start for our customers to just take the information that they have and just keep drawing more conclusions and keep implementing more, you know, gathering more information that's more specific, and just keep building on it. So this is definitely still work in progress. There's just so much that can be done for this project moving on. I feel like we scratched the surface, but once again, did the best we could. So for conclusion and recommendations, I've mentioned most of this already, but you know, 3-day pass and total search count are the two negatively correlated features that we found. So once again, you know, does it make sense to get rid of 3-day pass? Does it make sense to do a trial run? I mean, we would encourage that to see what happens, but there could be some financial implications. So more information is definitely, you know, required in here. So consider the value of it. Why am I not doing the full screen? Okay. There we go. Okay, never mind. Sorry, guys. Introduce additional questions. So what we also did is we sliced before based on whether they reactivated, you know, whether they upgraded and downgraded. Those did not prove to be statistically significant in this case, but it's also probably a good question to ask why you're reactivating. Just learn more about these people, what drives them back in. And hate to say it, but you know, more research is required. I think every research project ends with like, do more research. I hope we were able to provide some direction in here. But you know, there's definitely way more that's going to happen in Property Scout and real estate data space, you know, once it stabilizes and progresses. So that'll be it. Thank you so much. Anybody has any questions?
All right, thank you, Team 5. I would like to now invite Project Team 6.
Do we have the microphone too?
This is on, and let me just get the screen on for you one second.
Thank you.
From here, we'll see.
With the arrows there. Is that okay? You guys are all set.
How will it go further? Okay, this one.
All right. Hello, everyone. We are Team 6. We are Team Schnitzer, Team Amazing, I guess. But yeah, here is our presentation about our unscheduled delay analysis project with Schnitzer. My name is Sam. I'm the team lead for the last 2 quarters. And here it's my amazing teammate, Nupur, Kylie, Karan, and Roger. First, we wanted to say thank you so much for the Schnitzer team, Stu, and UW CBA team for making this project happening to us. We have been learning a lot. Really appreciate that. And our agenda today will be executive summary, and then moving on to the live demo of our dashboard and model, and we will end the presentation with the findings and the recommendations. Now, Nupur take you guys to the executive summary.
So, hello everyone once again. I'll give you a little background about the company. So, Schnitzer Steel is a metal recycling company, scrap metal recycling company. They process and manufacture different kinds of metals. They can be high grade, low grade. They also manufacture different commodities like wire rod, rebar. And as far as storage goes, their data is tracked in Oracle database. They have different information in their data set, like kind of commodity they are manufacturing. By commodity, I mean products, and what kind of delay is happening in the steel mill, what kind of equipments they are using, what kind of different areas are there in steel mill, in which shift the crew is working in the mill. Yeah, they do that. And here comes the important feature of our project, that is delay. So delay means the amount of time by which any event or action is postponed or held back. And by event here, I refer to the day-to-day mill operation that is being delayed. So this is the star of our project, which we are trying to figure out why that delay happened in the steel mill. And yeah, so here comes our business problem and goals. So our business problem with the steel mill was to figure out the kind of environment by which the delay is happening, or the kind of factors which is affecting that delay. By factors, I mean what kind of environment, in which area the delay is happening, with which equipment the delay is happening, like which crew is working on that time. So all this factor. We can also call it unscheduled downtime, which we are trying to figure out in which environment the unscheduled downtime is happening. So to resolve this problem, we built a model that is a decision tree model. We also improved our model by using cognitive services. We used text analytics for that. And we predicted delay reasons and delay areas based on the delay comments that were made by the steel mill crew that were working at that time. They used to enter any reason. They used to enter the reason they feel why the delay happened. And yeah, so here comes our kind of overview about our steel mill. This diagram is from the Schnitzer Steel. And this is I know it's a very complex diagram, but I'll try to explain. So this consists of different areas. Suppose any scrap metal comes into the steel mill. First, they'll go to maybe reheat furnace or maybe a hotbed. So these are the predefined steps that they follow, and different areas. So mainly for reheat furnace, maybe they'll melt it, then they'll move to hotbed, then cold shear. So these kind of predefined steps they do. So now Kylie can take over from here and explain the model.
So let's model a steel mill, shall we? Here's a little bit of a cross-section of what we're kind of working with this data set. First, you can see we have a really robust comment section, and we'll talk more about that later. Here, over in the commodities, grab the mouse, you can see that we have a bunch of different things that Schnitzer creates, right? So that WR is wire rod. They have filter on. Rebar is their most common though. Rebar, like you see when they're building bridges, long strips of metal, corrugated surface. We can see there's different types of delay categories. It can be unknown, it can be something to do with the finishing tools, it can be guide shop, IT, et cetera. So there's a lot of different reasons the mill might have a scheduled delay. We also have different product families. We have coils and longs, which are obviously going to go through different machinery. I mean, you're not going to coil rebar, right? But you're going to coil wire rod. There's lots of different areas. We're going to talk a lot about the bundler because that's where we have the most delays, second to the cold shear. Reason is really what happened. You can see the big unknown bar. That's a foreshadowing. We'll talk a little bit about that later. Bar caught being the second most common thing that happens in the mill. Another thing to note about bar caught is it happens in lots of different machines. So you can see how like getting a bar caught and maybe like a stacker is like pull the bar out, but getting a bar stuck in other machinery might be a longer issue, right? But they have the same word, right? So you can kind of see how things will change if I just click on rebar. So you can kind of see how different processes are at work in the mill with this full delay data set. So what we use to model this mill is what they want to know is what kind of factors lead to a long or a frequent delay, right? So this is a decision tree model. Keep in mind this is not optimized for prediction. It's optimized for readability because what we really want to know is what's happening in the mill, right? So you can see that first node is reason, like we talked about. That's what happened, what went wrong at the time, right? And that first node means that that's really the driver of the model, and we'll kind of see that coming on. It's our most important feature for this. So if you haven't read a decision tree in a while, kind of how that works is like if it's one of these reasons, then you're going to go left, and if it's not, you're going to go right. Right, so if some of these reasons are causing longer delays, and if it's not, then it'll be a category or equipment. So Schutzer can look at this and be like, okay, there's certain reasons that are causing us problems, and among those reasons, maybe we can look at these categories, and going further, maybe we can look at some equipment, right? Some things we're going to keep in mind here is the mean average error and the RMSE, right? The mean average error right now on this model is about the same length as the average downtime the mill experiences, which is about 10 minutes. And you can see the RMSE compared to the MAE is quite large, which means when our model is wrong on this, it's quite wrong. And this is really due to the number of processes that are at work in the database, right? So it doesn't really work to do a full mill model. So something we're going to do is model by area. Something that Schutzer needs to do is document each process and really make a record for each type of process that there is. Like we're running long wire rod and we're going to coil it at this dimension and we're using this specific type of grade of metal. But they don't. So what we used was their most common commodity and their most common area to try and kind of slice this a little bit. So here we can see the mean average error and the RMSE have really gone down, especially that RMSE, which means that our model, when it's wrong, isn't quite as wrong as it was before. Once again, we can see that reason is the primary node. We'll see this across because reason is really the driver of this model. And you can see here for the bundler, there's some equipment issues as well. Now we'll go back to the unknowns. Remember that big unknown bar? Well, unfortunately, we have about 60% of unknowns in our database, which is really just because it's not a required field for mill staff to put in stuff like reason and area. They didn't know that it was driving the model, but it is. So something we thought we might be able to do is use text analytics to figure out from the comments, which is very robust. They almost always have comments in. Just to see if we can backtrack and figure out what those reasons were just from the comments, right? So we used Python TF-IDF scores, which were super powerful. They predicted at about 88% for this reason. So you can see here what kind of happened. We had all these unknowns. You can see here how they split out. As expected, we got a lot of bar caught. That's the most common one, so we suspect this is pretty good. You can see the knowns we had before and the knowns after. So now when we model rebar in the bundler with the addition of the predicted fields, you can see that we've really improved. We've moved that mean average error down, and it's really hard to get that number to move. And we can see that the RMSE is improved too. Bigger issue, unknowns in area, because this means I don't even know what equipment that you're working on. I don't know what process we're talking about, right? So we had all these unknowns in area, but we still have that robust comments field, and the TF-IDF scores were so powerful we decided to use it on this. So we got about an 80% accuracy on this. You can see here how it broke down. It's all the reheat furnace. And I'm sure you all remember Nupor's chart before. The reheat furnace is the first step in the mill. It's exactly what it sounds like. They put the metal in there and they heat it up, right? So we met with Schutzer, we talked about this result because it's quite surprising to get this much reheat furnace. And they said, well, it's very possible that what's going on is A, some bad data management practices, and B, that this could be the result of something going on farther down line, but the result of it was that they turned down the furnace, right? So then that became like the primary thing that got into the comments was, well, we had to turn down the furnace. So we predicted that out and got all that reheat furnace. But then we still have the issue of the unknown reason, and we need the reason in order to drive the model, right? So this is going to be a really tough prediction because the reheat furnace data entry is quite bad. Look at all those unknowns. We don't really have a lot of knowns in this database, but we ran the TF-IDF anyways. The prediction isn't great, it's about 55%, but there are a lot of different reasons, and we didn't have a lot of knowns. So you can kind of see what came out here. Resync level 2 and wait for heat, those are both a result of turning down the furnace, basically. You can see that we don't expect this to be a really good prediction because we only had 549 knowns before, and we ended up with about 4,000. And indeed, when we go to model it, the model's a little rough. So this is something that's just going back to work on. They're really concerned about this issue with the reheat furnace and making sure that they code things correctly so that they can figure out what's actually going on in the mill, since this came out to be the biggest driver of delays is this reheat furnace. So we'll go back to our recommendations.
All right. Thank you, Kylie, for showing our models and dashboard to the audience here. So moving on, we will talk about the findings and the recommendations. Throughout the project, we actually have a lot more findings and recommendations, but it's all tied down to these three main one. And this is not just recommendation, but these are the steps that like Snitzer have already told us that they're gonna apply to their operational right now. The first one is that like currently our data set have a lot of different unrelated mill process representing the same data set. So when Snitzer using our model, they need to document all the different process and then study one process each time. And then the second thing is that survivorship bias represented in the data set. So Snitzer will have a follow-up project using both operational data and delay data on that next project. The third thing is that like comments can be used. We can use text mining to leverage the comment to predict the unknown value for different fields. But however, it's not a long-term solutions. Snitzer will need to make a change into the database that make all those fields like area, equipment, and reason mandatory from now mandatory. And that's actually everything. That's the end of our presentation. We are open to questions.
All right. Thank you, team. We are now going to view Project Team 7.
All right. Good morning, everyone. Still morning, yes. I hope the coffee is helping. We're Team 7, and I'm going to wait. Awesome. I'm not repeating the coffee line, but we're Team 7. And we had this opportunity to work with Sound Credit Union and an amazing BI team there, led by Jason. So let me walk you through the agenda. I will be talking about the project overview, followed by Chaitanya, who will walk you through the data mining process, and then Becca will take you through what we did with the modeling. Hema will walk you through the visualization on a Tableau, and Shreya will walk you through the deployment on web app. Let me start with the most concise way of saying what was the problem statement at Sound Credit Union. Their concerns were centered with member retention and youth engagement, and that's where we stepped in. We proposed a solution to create a predictive next best loan offer to all the members of Sound Credit Union to offer like the right product at the right time to the right individual to ensure that there is easy way of retaining the members. So we proposed to give them some analytical insights, prepare dashboards and KPIs, create the predictive model, develop a deployed web app, and also a word cloud to understand the sentiments of members using Sound Credit Union products. Let me show you the word cloud. Now, we do see positive and negative feedbacks, which makes it more real, of course, but we ended up circling around more positive feedback, which tells us Sound Credit Union is definitely doing something right. Let me take you ahead with our project scope. So we restricted our scope loan categories into the 4 major loan categories that Sound Credit Union has. Okay, thank you. And those 4 categories are home loan, personal loan, credit cards, and auto loan. There is an opportunity for Sound Credit Union to further dig into the subcategories of these loans, but for now, we restricted the scope to just these 4 major categories. The second part of the scope we restricted was our predictive model. We bifurcated our model into 2 parts. The first model will be for all the members who've had previous loan experiences with Sound Credit, and the second model will be for members who've never experienced what it is like to have a loan with Sound. I'm going to pass it over to Chaitanya, who will walk you through the process further.
Thank you, Vijay. So let's go through the solution architecture. So we have the data in Sound Credit Union database, and they have downloaded it in extracts and uploaded it to the SharePoint. So once they uploaded in SharePoint, we downloaded that and we uploaded into our university database using SSIS. So once the data is available in the database, we use Tableau for visualization. And then once we did the visualization, we use R for cleaning the data. So now that we cleaned the data, we extracted the data which is required for our model. And once we have the data, we use Azure and Python for modeling. So once the modeling is done, we use Streamlit for deployment. Now let's go through in detail of what we have done. So let's go through the data preparation. So as we said, we had millions of records. So we had to use SSIS to upload the data. And once we uploaded the data, we have to do extraction, which is used for the model. We can't use the data what it is, which is in the database. So for the extraction, what we have done? We have 2 models. One is customer with loans and customer with no loans. So for customer with loans, how we extract the data is, suppose a customer having 2 loans. So when a customer opens his second loan, we are trying to identify the characteristics of the first loan, like the loan interest, loan amount, as of when the second loan is opened. So the customers having 2 loans and will be focusing on their first loan statistics. Now that we have the first model extract, we are we move on to customer with no loans. So for customers with no loans, what we are trying to do is that we have customers who have taken first loan. So when they have taken their first loan, we are trying to identify the characteristics of their accounts and savings. Using these particular patterns, we will try to identify and predict the next best offer for customers who are not having any loans at all. Now that we have the data extraction ready, we have done the data transformation. So in data transformation, we have so many date columns which we can't use directly in the model. So for data transformations, so we use date columns to convert into numerical columns. For example, loan open date, loan closing date, we convert them into loan duration. And we have so many categorical columns and we can't use all those. So we restricted that into less than 25 distinct groups. And then we have many dimensions as well. So we have to make them into measurable attributes by aggregation. So in summary, we had millions of records, like over 20 million and 700 plus columns. We segregated that into less than 16,000 to 18,000 rows and having less than 75 columns. Now that our extract is ready, we started doing modeling, which will be explained by Becca.
Thank you, Chaitanya. So I'm going to do a quick overview of our model here with this Azure ML Studio layout. In the top half of this visualization, you can see where we performed our data cleaning. So we replaced negative values, dealt with any missing data, and did some mathematical transformations to even out the distribution of some variables. Leading into the bottom half of this image is where we began training our model. So we split the data and normalized it, and then trained on a multi-class decision forest. We did train on a few different models, but this one provided us with the best performance. And then leading into the end is where we evaluated our model. So here we can see the results of our first model. You can see that there's an overall accuracy of about 56%. And looking at the confusion matrix in the bottom, we can see by the darker blue colors that our model was better at predicting auto loan and personal loan. So we wanted to understand that a little better. So when we look at the frequency of these records in the data set, we can see that there are many more records for these two types of loans, which allowed our model to train better and understand those records. So leading into model number 2, we can see that this model also had about a 56% accuracy, again with auto loan and credit card loan having a better accuracy due to those higher records in the data set that we use for training this model. So with everything we've learned over the last year with Sound Credit Union, we just have a few recommendations. So to improve on the models that we've created here, we would suggest adding more data. So that could be demographic data or even marketing data in tracking what offers are made to members and how the members respond to those offers and maybe even why they responded the way that they did. And then also reevaluating the columns that we used, because we did start with over 700 columns. We had to omit a lot of those in the beginning. So dive a little deeper and see if there's any importance in those variables. And then finally, if Sound Credit Union would like to offer a more specified offer for their members, they could use subcategory of the loan for the predictor to go beyond the 4 loan offerings that we analyzed here. With that, we will get into the exciting part of this presentation, and Hima is going to take you through a demonstration.
So this is the interesting part we have. So today we are going to present demo of 2 things. One is tabular dashboard and another one is a web app, which is the deployment of our predictive model. Firstly, I'll walk you all with the tabular dashboard. So loans being our area of interest, we have created a dashboard for the loan data. So we'll just get into it. Yeah, so loans, as Becca explained, we dealt with only 4 types, major categories, but it holds the subcategories which can be implemented further. So this dashboard helped us identify few significant patterns, metrics, and the trends the data had, which helped us understand the data better. So yeah, so sorry about the inconvenience, but I think it's because of lots of data we have, so it's taking a bit time to load. So this was a part of our second quarter, which we developed this dashboard. So this was the time where we had bit less data, and in quarter 3 onwards, we received more data. And yeah, finally it's up. I know I said it was interesting and we kept you waiting. Yeah, so as you see, the dashboard lists out the few of the significant KPIs which we identified. As you hover on the trend line, you can read the significance and the specific details about that KPI. So coming to the bottom section, it gives the percentage of each loan category opened annually. As we scroll down, one thing we noticed was initially it was only the home loan, then personal loan, then slowly other categories joined it. So this was according to the data we had, and from 2003 onwards, we were able to identify all the categories being coming to the KPIs above, so we have added a drill down feature to further analyze them. And let's get into total loans. As you see, it gives 3 different graphs, one with respect to categories, one with respect to city, and the other one is duration. So with the help of the filters, the user can read specific to any subject. Like say, if you click on Tacoma, the user can read the details with respect to Tacoma. The other graphs get updated, and this helped us identify the trends with respect to cities and categories. Let's get back to the main dashboard and check out another one, maybe open loans. So as you see, here also we have used 3 different graphs. One is with respect to category, another with respect to years, another with respect to duration. So one thing here, interesting thing we identified was there were many open loans which were aged more than 30 years. So that was one of the interesting fact we could study with the help of this dashboard. So this drill down feature we have applied to all the KPIs listed on the dashboard, which helped us study the data better. So yeah, this was about the dashboard. Now let's get into web app.
Thank you, Hema. Now let's move to our web app. We have built this using Streamlit by configuring it with our Python code. So as you can see, the left side, we have some welcome message which describes about the 2 models, what we have. On the bottom, we have added a YouTube link, which can be any other video in future. For example, a live demo of this whole web page, how it works. For now, we have just kept it a dummy video. In the center, we have 2 buttons, which is our 2 models. So let's click on the first button. As you can see, there are some fields which populated. These are the best features which were defined by our model. For each field, we have added an icon which describes about what that field is about. So all you have to do is enter some values in the field, and for the demo, we have already entered it, and click on that button. So once you click, within few seconds, we will get what is the next best offer for that member. As you can see, it says next best offer is personal loan. Now we understand that it is very tedious job to do this thing for multiple members Sound Credit Union has. So we have added a feature for bulk upload and prediction. You can download this template by clicking on this link, and it will download a template which looks like this. This has all the same features which was there in the screen. All you have to do is enter the values and click on the browse and upload it. Once you upload, within few seconds, it will create a predicted sheet which you will download using that button. And the last column is all the predicted values for all the rows which you have entered. So this is how the modeling works. Same thing can be done with the second model, which is member with no loans. So as you can see, once we click that button, the similar feature is there, and you can do the same thing with that too. We have, as you can see, it says the next best offer for this member is credit card. And we have also added an image with whatever it is. And the same download and bulk upload is there with this too. Now moving back to the last feature we have for this, we have also added an interactive bot. So you can ask any question with that bot and it will answer it. For example, we are asking what is the maximum load available, and it is answering it. Another cool thing about this is the bot is able to recognize even though if you are entering wrong. For example, the spelling of maximum is wrong, but it can recognize it. So that's all what we have for the demo. At the end, I would like to thank you, all the professors and the Sound Credit Union team for their immense support throughout the year. With that, we are open for any questions.
All right, project team 8. Testing, hello.
All right, thank you, everyone. We are Project Team 8, working with the South Sound Military's Communities Partnership. Next slide. First, I'll start off with everyone here. My name is Jordan. We got Cameron, Nina, and Jared. Michael was unable to attend today because he's sick. Really bold playing hooky on your last day of grad school, but bold, but admirable. So our agenda today will be looking at our clients and partners, our dashboard, which will go into a live demo, as well as a predictive model that Cameron will walk us through. First, we'll like to acknowledge this collaboration between the University of Washington Tacoma CBA, as well as the South Sound Military's partnership. Without this, we could not complete this important piece of research. And if your name is up there, thank you. First off, we'd like to look at what JBLM is. It became what it is today in 2010. If we've driven anywhere south of here, if you're in Tacoma or going to Olympia, Portland, you probably have driven through it and been stuck for a little bit in the traffic because it's awful there for some reason. But it is home to over 50,000 military personnel, families, and civilian employees, and takes up roughly 400,000 acres. And it is the largest base on the West Coast and a place for deployment for the military. We got to work with the Thurston Economic Development Council, looking into in-plan analysis, which we'll dive into in our live dashboard, and we'll look at the input table and NAICS code stuff when it's relevant. I could talk about it right now, but it's better with an example. It's slightly confusing. So our spring quarter success, we completed our regional economic impact analysis, which is done on a biannual basis. This is the third iteration. It's done in 2020 and 2018 before this year. We got into our dashboard and as well as the predictive model. So, go back. So some of the high-level highlights that we looked at from the $600 million roughly in Department of Defense contracts, we were able to, through impact analysis, see that the presence of JBLM created an additional 85,000 jobs, which in turn had $1.4 billion in tax revenue, and included on top of that, $5.66 billion in indirect and induced impact by the presence of JBLM. And then we'll go into our dashboard. I think you need to close out. No, it's not. There we go. So this is our prototype dashboard that we created for our client. And we had this kind of idea of it being twofold. One, for an internal-facing dashboard for our client to use to have all of our figures in place for them to just go and quickly look at, as well as an educational purpose for the public. Our client oftentimes has to work with lawmakers to show the importance of JBLM, and so it has all of our figures right there instead of having to point to a boring 20-page report all the time. So we had a few definitions there about our client, as well as what the base is and what in-plan analysis is. So this is kind of like our high level, again, look at what is in our report. It's a little bit prettier, in my opinion, to look at. So along the top, we have a lot of the stuff that went into our analysis, the implant analysis, and then on the right side, we can see the stuff that came out of it. So there's 3 different types of outputs from implant: direct, indirect, and induced. And we'll dive into those later as we have separate tabs for each one of those. So this is the input table that went into implant analysis. It is a bunch of contracts. There's some, like, what would you say, Cameron? There's like 100,000 some odd rows and a bunch of different categories. And so we had to filter our data to pull out the NAICS codes, which stands for North American Industry Classification System. And this is a 6-digit number that every business has. And what we did was we took the first 3, because how it works is the less numbers are, the more broad it is. And when you get down to 6 digits, it doesn't really, it's too delineated. There's no way to see trends over time. So we pulled that data into the 3-digit and ran the analysis, because we could then group everything by 2-digit codes, so we could even see within smaller groups there. Next slide. So the next 3 pages here look all pretty much the same layout. We have our industries, which is that 3-digit NAICS code again, and we see from the implant analysis what is being affected mostly at the direct level. And so the direct level, we have a definition of the direct impact. It's like, what is the people who work at JBLM, what are they going and spending their money? Where is that money going? And then we have a few little figures up at the top about how many jobs are being generated, how much are those wages. And the next couple of slides all look like that, just with slightly different numbers, but it's the same stuff pretty much. And then we wanted to see also the comparisons between all of them. So we were able to grab all of our indirect and induced, and then we were split it by the counties. And because each of the Department of Defense contracts were breaking down into Pierce and Thurston County. That was our geographic scope for this analysis. And so we were able to see that healthcare and real estate were the top 2. Those were the biggest impacts, and then how it was split up between Pierce and Thurston County. And I will pass it off to Cameron for the model.
Thanks, Jordan. So for this model, you can go to the next slide. We had the problem statement of, can we predict the contract price that is awarded by JBLM from the information within the contracts themselves? There were some difficulties, though, as in every problem. The first, and the one that you see pictured here, is that most models work best when the data is normally distributed. This is not normally distributed in any stretch of the imagination. There was one contract that was awarded for $2.9 million, and that really skewed everything. So that was the first problem. The second major problem is that there were 2 numerical data points that we could point to. Everything else was in a categorical text format, which if you want to have a numerical prediction, having some sort of precise recommendation and prediction is really hard when you don't have all of that numerical data to kind of pull from. So what did we do for solutions? The first thing we did was we drastically reduced the range of the data that we were looking at. We reduced it to the interquartile range, which is the 25th percentile to the 75th percentile, and this got rid of all of the outliers. We then used a log transformation to make it more normal, and in many different senses of the word. But what we then did with the categorical data is, because there were so many columns that were categorical in nature, we used one-hot encoding to make them all numerical, so that way we could so that way we could make them into the models. It had a ton of variables. So then what we did was we used principal component analysis to figure out how do we reduce the number of variables, and we reduced it down to about 15 variables that represented 80% of the variation, and then we rinsed and repeated. We looked at what was in the principal component analysis to see which ones had the most impact on the model, put those back through, and reduced it down to about 200 coded variables that then represented a much, much smaller portion of the overall data set because we were picking and choosing which categories had the best impact on the final contracting price. And so that drastically reduced the data set. At a high level, and reminder that these are all pulling from different variables. So each of these can pull, like, this code from this column is important and this code from this column is important. But it makes sense. What was the type that was used in the competition for the award? What was the awarding organization within the DoD? What were the specific, who was the specific recipient? And that can be used based off of historical data. What was the location, both within Pierce and Thurston counties, and the information more specific inside? And then also, obviously, with NAICS code and a bunch of other things that would make sense that would impact the cost of the contract, like how do we get the material to the base? And for the final model, we went through ordinary least squares regression, k-nearest neighbors, random forest, and XGBoost. The XGBoost was the most successful model. The mean absolute error for the model was about $11,000, where the mean value was 18,000-ish. To compare this to the linear regression, which was about a 0.42 R squared, that had a error of about 25,000 for the root mean squared error and an absolute error of 14,000. So this is better than 0.42 when comparing it to the linear regression. But with that, that is what we have done with the SSMCP during this last year. Are there any questions? Okay, thank you very much.
All right, we will go ahead and take another break, and let's resume at 11:10. Thank you. Yes, I did. Okay. Great. So this is going to be replacing the
Made up some fake class store average salary. So. A little bit, yeah. Not too much, but
Okay, everyone, we will go ahead and resume with our project team 9.
Hello, everybody. We are honored to present Tacoma Power Future Asset Spending Trend. The agenda will introduce. The agenda will be, we have the introduction, the problem statement, the project phase, the summary and recommendation, and the live demo question at the end. Thank you to the faculty, the Miguel School of Business, especially to the Center for Business Analytics, to support us, guide us to achieve what you're presenting today, the high-level projects. First team, myself, Kadi, the leader, Brandon, Charming, who is not here, Evan, Wazago, and I will pass to Brandon for more detail for the problem statement.
Thank you, Kadi. So I'm going to be going over the problem statement that Tacoma Power had for us in this lovely project. So Tacoma Power works with a lot of electricity, but you're wondering how much does the assets cost to maintain? That is what they're looking for. They need a way to look through the data they have and be able to forecast the spending that they're needing to calculate for. Because you have like hydroelectricity, poles, substations, so many different factors and assets that actually need to be calculated for. They wanted us to try to dive in and be able to create that forecast and look at the trends. They also want to know about like the abnormalities that could be found within the data set that they currently have. So we could actually split this into 4 different objectives. The first objective is to create a tool like a Tableau dashboard that they're looking for to be able to create this forecast and be able to grab all that information that they're looking into. Second, they would like to have a forecasting that's based off the work type orders that are being done. This would be, like I said before, the poles, the substations. How do you really break these out? Like, how can we separate these forecasts? And then third, they would like to look into KPIs that are reasonable and understandable so they can actually be like, hey, where are we at currently? And then the last one is to find the apples amongst the oranges. What is not fitting within the data set? What's different? Next slide. So in phase 1, this is basically where we kind of got our feet wet in understanding who Tacoma Power is. What do they do, and what are their long-term goals? We got a great repertoire with Julie, our contact, and she was fantastic. We had regular meetings, and honestly, it was an easy process to start. And then when we went into the second phase, we would get data in a lot of different batches. It wasn't all at once. It was in different time periods and trying to understand how do they connect. How do the work type orders connect to the equipment? And then really trying to dive into the data. This phase really did kind of bleed into our phase 3 a little bit as well because the data cleanup was quite extensive. So for the cleanup phase, I'm actually going to hand it off to Evan.
Thank you, Brandon. Like he mentioned, the data cleanup phase was very extensive, and I think for our group and all the other groups here that is the case for a lot of us. So we started with obtaining our data, which can be a bit of a slower process. We got our data in batches a lot of the time, and so we were constantly adding to our data set. And that's kind of where our SQL server comes in, is where we can automatically import that data each time we get a batch from our client. And then we moved on to the data pre-processing, the imputations, creating of calculated fields and things of that nature. And then we constantly upload back into Excel, into SQL Server when we have edits made. And here's a high-level overview of our data architecture. As you can see, the different types of data that we receive going into the SQL server. And there we can export and query to clean the data set and combine different databases together. And then being exported again to our deployment systems in Tableau and ML Studio. And so for phase 3, develop, we had a continuation of data understanding through basically all 4 phases of this project. We consolidated our data set to transform them into a usable format. This is largely a data reduction phase for us in the phase 3, where we identified a lot of the outliers. We had a data analysis plan for each of the 4 analytical approaches and continuous meetings with the client to really understand the discrepancies we've been finding in the data and understanding where those holes where they can be filled with her knowledge. And then we created our Tableau visualizations and data modeling through ML Studio. And for our data modeling, this is largely a proof of concept model using a boosted decision tree regression to predict total cost for Tacoma Power. So this flow here represents the different pills that the data goes through to be evaluated by the model. And then the coefficient of determination, or the goodness of fit metric, is seen at the bottom there. And this, even though it's not that great of a R-squared, it is a model that helped us understand that the data that we cleaned is working when comparing to older models. So this helped in our data that we used in our dashboard, as you will see in a bit. Next slide. And so now we'll hand it off to Nat to do our phase 4 findings.
Thank you, Evan. So here's come phase 4, our final phase, which is the deployment phase. First, we still continue our analysis of the data and score the data. And we also continue to build upon our domain knowledge and understanding on the data sets. Next, we consolidate our data set to create a proxy data set. To give you a brief understanding on why we decide to go ahead and build a proxy data set. First, like Evan has said, we have delete the outliers and reduce the data set. But with the reduced data set, we still found that 87% of the equipment categories are still missing. So with our determinations of the data abnormalities, we make an executive decisions to use a proxy data set to create a dashboard and to create a proof of concept to show Tacoma Power what their data set could have been done. Next, we have the technology plans and the dashboard development, and we deployed our Tableau dashboards. Before moving on to our live demo, I would like to take you to the cognitive analytic techniques that we have done. We have done 2 techniques, which is one is the key phrase extraction and the name entity recognition, or the NER. First is the key phrase extraction. This is similar to the text mining, in which we extract a key text from a long phrases in our text column and get the data, as you can see. This data is getting from the operational short text, and it could be extracted as equipment usage, the DCA, the analysis oil, as their top 3 most frequency, and this data could be filtered and analyzed accordingly to Tacoma Power preference. Next, we use the name entity recognition, which is the NER, which will separate the word or the phrases into 3 categories, which is a person, organization, and places. And this also can be filtered and analyzed by Tacoma Power as well. And this could help benefit them in terms of analyzing more complex data set. And this is our cognitive model that we have done. We did it in ML Studio by pre-processed data to the NER analysis, and we have a clean missing data to the key extract key phrases from the text. And on our next one, before we moving on to our live demo, I would like to give you a brief summary and recommendations on our projects. So throughout the years, the FAST team has successfully identified opportunities and problems for Tacoma Power, and these projects has helped them to monitor the trends, identify data abnormalities, and to determine their key success. And our key recommendations is to improve data qualities and accuracy to utilize more of their historical data. And also, the second one is to understand which fields and to drive their potential insights. And this will become in hand with their new way of data gathering to improve their data quality as well. And in our next step, we will hand out crosswalk to mimic our dashboards and help them implement our dashboards in their preference. Now let's go to the live demo. Here is our live demo dashboard in which you will see the key KPIs up above, and there will be a distribution map also down below. The key KPI will consist of cost, labor hour, and order quantity, and the total number will be in year-to-date of the key KPIs. Whereas the percentage change will be compared with the 2 year-to-date. This is because after consolidating with Julie, this is how Tacoma Power would like to compare the budget and with all of these metrics. And this year-to-date could also be changed according to what they preferred to analyze. In this case, now it's like May 31st. We could change it to the analyzing the whole year, which is December 31st, and the number will change accordingly to analyze the data. With these dashboards, we also create 4 more sheets, which you can see on the left hand, which is the Tacoma Power overview, work type KPI, work type detail, and the forecasting page, which can be scrolled to a click of a buttons. For the work type KPIs, we have kept the 2 metrics and adding the labor hour by type as well, for them to keep track of every work type detail. And this also could be filtered by the work type description on the left as well. And for the work type detail, this has helped them to keep track of their asset, on how much they have in their inventory, and also how this equipment is used in each of the functional locations. And lastly will be their forecasting, in which they can monitor trends and forecast their cost and labor hour accordingly. And this will be it for our live demo. Thank you.
Any questions?
Okay, Project Team 10. Is this off? Project Team 10, that's better.
Hello, good morning, everyone. We are Team 10. My name is Dustin Annis. I've got with me Song Kim and Zanab Shirin. And we worked with UW Tacoma, which was a great experience. Before we get into the project, I want to give a moment to thank the CBA team for all of their support. Both the faculty and the staff support has been truly helpful and amazing, so thank you. So today we're going to go through our project. We're going to talk about our statement of purpose. We're going to give you a brief snapshot of our project and what's been done since the beginning of the project. Is that better? Then we're going to go over some potential impacts of our data products, and we'll go into final recommendations. So I want to take a moment to thank the UWT Institutional Research Team. This was our sponsor, and they are led by Joe Lawless, the Chief Strategy Officer. We worked very closely with Alice Few and Andrew Chamberlain. They're the IR analysts here on campus. And Lorraine Toller, who is an administrative specialist and was really helpful with our team as well. And then a thank you to all the faculty and campus leadership that attended our question and answer session. that really helped us refine what our problems that we wanted to address were. And to get into that, the problem statement we received was pretty vague. It was essentially, we are trying to figure out how to make data decision-making more transparent across campus, and we want some dashboards and models that might be helpful for doing that. So there was not a particular metric that they gave us. It was sort of open-ended, so we were able to really sort of explore the data and discover what we wanted to look into. So we sort of conceptualized our objectives with 3 categories. The first is, in order to really make sure that we're giving UW-Tacoma the tools to continue to tell their story and to do so in a more transparent way, we need to understand what the industry leaders are doing. And so the first major task we completed was looking at their peer institutions, of which there are 7, and then looking at industry leaders to see what approaches those different schools are using. And then, obviously, our solutions need to be transparent, and they need to be really easy for people to use and understand. And then the agreement that we came up with was we would deliver data products for 3 metrics that aren't currently measured by the institutional research department. So this is our project snapshot. This gives you a little bit of a timeline, similar to the other teams of what we completed this year. So we started by drafting a project objective and scope. This changed a lot because, like I said, we were given a really loose project scope. So we've changed this quite a bit over the year. But like I said, first step was to do that industry and company analysis. And then in the second quarter, we really began to dive into what the peer institutions are doing. And I guess the takeaway there is most of the peer institutions that UW-Tacoma has are presenting data in tables and PDFs. And so the fact that UW-Tacoma already has some really great dashboards and some ad hoc reporting, I think they're really a leader in terms of their peer institutions. And then we completed our data management and data analysis plans. We used Census Day data. This was sort of a sample of the full data set that we used to do this. We later got full access to student academic data in winter quarter. So when we got that, we decided on our set of metrics, and we'll talk about that shortly when we go into our live demo. We developed some prototypes that we could use and show the client. We had weekly meetings with them throughout the year, and we incorporated their feedback as we met with them week by week to improve what we created. And then spring quarter was all about taking what we had already done and sort of improving on it. So we really refined our visualizations. We worked on our predictive model, which still needed some work at that time. We had to change our data set for it quite a bit. And then our outcomes, we've created a predictive model, and the predictive model essentially is used to address a pretty specific UW-Tacoma problem, which is that a huge percentage of our student population is undeclared, which means that the decision makers aren't entirely certain where students fit into the departments and majors until they either declare their major or graduate. And for some students, that might not be until their very last quarter. So there's sort of a lot of uncertainty around that. We created a dashboard that looks at drop, fail, and withdrawal rates of students. We created dashboards for graduation and retention. And then we created a Power Apps data request, which is essentially conceptually a project management platform that will take the data request process out of email and put it into something that's able to be tracked over time. So now I'm going to turn it over to Zanab, who's going to walk us through the predictive model and the dashboards.
First, we'll just start with the predictive model, where we are going to predict or to categorize students who have their undeclared majors. Students have undeclared majors for various reasons. Either they are unable to choose the majors because they have like various courses across their study period. So we try to classify the students who have undeclared major when trying to predict students who fall under, based upon their major department, we have got 99% accuracy, where it seems bit high as because we have taken the data students who have graduated. So the accuracy is bit high, and when trying to classify students based upon the student ID, major ID, when trying to predict students who fall under major ID, we have an accuracy of around 88%, which is compared less than students, rather trying to classify students who fall into major department, as in major departments have are easier to classify rather than the major ID. The variables that we have chosen for the predictive model, we had various discussions with the stakeholders and with the institutional research team on choosing the variables which should be relevant to students, to classify students into their corresponding major IDs or major departments. When trying to classify students under major ID, we have an accuracy of 88%. And then next, we move on to the retention and graduation dashboards, where we will see how the course offerings impact the students' graduation and retention. Here we are looking into the graduation rate of students who graduate in a period of 4 years, 5 years, and 6 years. There are various reasons for students to have their graduation rates from 4 years, 5 years, and 6 years, as students have some students, they try to take up a running start, as in they try to complete their first 2 years during their 11th and 12th grade. So maybe that could be one of the reasons. And some students who have a full-time job and to take up the college course, and that could also be one of the reasons for students who took time to 4 years, 5 years, and 6 years. And their graduation rates vary from 72% to 77% over the period of 4 year, 5 year, and 6 years. Next, we are going to see how the student demographics impact the graduation rates, where the graduation rates are classified based on the gender, resident category, and by ethnicity. Here, on the resident category, we have international students on the highest, where they graduate on the highest point than compared to the domestic non-residents and residents. When compared to the gender point, both almost have on equal point, and female on the has the highest count. And when compared to the graduation rate by ethnicity, almost everybody has on the same pace, though Asians have an highest of 81%. Next, we move on to the retention part, where we see retention by demographic details over the. The data shows over the a single quarter results of retention and a year's retention part. Here again, for the demographics, we're going to see 1 year's retention data as well as a year's retention data, where the similar to graduation, we have been seeing the resident category and ethnicity. Now over to Dustin for the Power App form demonstration.
Don't forget drop fail.
Oh, yeah. Next, we are going to see the drop fail withdrawal dashboards. The the good drop fail withdrawal rate is actually between, having seen over the various universities, the good rate is supposed to be around 12% to 14%. But we have here around, it varies between 26% to 30%, and the university is trying at the back end, they're trying ways to see how it can be reduced. And we also have a drop fail withdrawal rate for almost 8-year period across the various quarters. And over the 8-year period, we have a consistent drop in the summer quarter, whereas when you see the rate in the Vetran description, when compared to the Vetran students, the civilians or the who's not a Vetran has the highest drop fail withdrawal rate. And we have also had the drop fail withdrawal rates for the across the major departments, whereas in the major department, the School of Science and Technology almost have the highest drop fail withdrawal rate. And when you see the drop fail withdrawal rate for across the degree pursued, we have showed the rates for the bachelor degree and the master's degree, as we don't have any major rates for the doctoral and graduate certificates. That's all we have for the visualization part. Over to Dustin.
All right, so I want to quickly walk you through the Power Apps form that we created to serve as a project management assistant for the institutional research team. As I mentioned previously, this process is right now being done via email. And so there's a real danger that if the people that work in IR leave, there will be no institutional knowledge left of what the data requests that are coming in are, how important they are, and maybe some places to improve the ad hoc reporting so that we don't have to rely on IR to query SQL for all of these data requests. So it's pretty simple. There are 4 fields. You'll enter a deadline, a requester name, and a priority level, and then a quick description. Now, it's important to note that the IR team does have the ability to adjust the priority level. This is just sort of as an end user, I think this is really critical and I need an answer pretty quickly. And then we have a connected Excel online spreadsheet, which essentially will capture information from the Power Apps form. And then over in the Processed Requests tab, there is a spot for the analytics team to review the request, assign an analyst. So you can see I've assigned myself with a comment and the @ feature in Excel Online. I can communicate with the client through here. So if I tag the client in a comment, they'll receive an email that says I need some follow-up from them. And the benefit of this is that we really will be able to show the work that IR is doing over time, and we'll continue to receive that institutional knowledge rather than having it just exist in email. So then back to the presentation. All right, so in terms of the potential impact, these are what we think they are. In terms of the graduation dashboard, we think it really gives a heightened understanding to people that are decision-making across campus as to what students are persisting on time and who isn't. And this on-time thing is unique for UW-Tacoma because a large percentage of the student population is non-traditional. So they're not on that really traditional 4-year graduation path. So it's important to the chancellor, to the other decision makers, that we really show the full picture. That's why we used 4, 5, and 6 years. Retention is similar. We really want to know about the student's ability to persist after their first quarter and after their first year. Across the industry, we understand that if a student is able to be retained after the first quarter and the first year, they're more likely to continue and graduate, which is important for students having a perception of a return on their investment with the university. In terms of the drop, fail, withdraw rate, this can help to understand places where students may need additional supports in order to be successful. The predictive model is mostly used for resource allocation. It really will help the departments to have a clearer picture of which students belong to them so that they can make stronger arguments for resource allocation. And then, as I've mentioned before, the data request form is really about project management and increasing communication and transparency. So our recommendations are that UW-Tacoma continue to monitor retention and graduation. This is super important, especially because of the impacts of COVID. They've been felt across the entire education industry as they have most other places. And we won't know the full impact until we really have 6 years of data on graduation, because that's sort of what the university is interested in looking at. So some additional work needs to be done with that over time. And then really to continue to go out and figure out what the industry leaders are doing and find ways to deploy that. Obviously the challenge there is the really big institutions have a lot more FTE to work with in terms of having people do this kind of work. But we had a meeting with campus leadership, and there was a huge call for help with data around scheduling, academic success, and curriculum management. Now, curriculum management is super hard. There's only one system that really deals with it, and right now, nobody at the Tacoma branch has access to query that system. So the hope is eventually that can change, and there can be some more robust reporting there. And then we had some suggestions for future projects. The first is to look into drop, fail, withdraw rate more, and specifically look at what impact that has on retention. So if a student drops a course or fails a course, are they on average being retained after that? Because then we might be able to look at, okay, how can we intervene for these students that are in jeopardy of not completing their education? And then we also looked into teaching modalities, which was something that the client suggested. Unfortunately, the flags that are used for teaching modalities are still new enough that there's a lot of error in them. So we suggest that they collect data for a couple more years and then look into that more deeply. And that's all from us. Thank you. Any questions?
Okay, project team 11.
That's it.
All right. Last but not least, Team 11, here we are. Greetings, everyone. I'm Shannon Nadelius. I'm the acting project manager for Team 11, Westwood Shipping Line. That is what I'm talking about. Thank you for leading me into the next slide. Next slide. We have had the privilege of working with an amazing team at Team Westwood. There are 3 of them in the back with us. We have Jean, KS, and Steven. Thank you for being here. We've also worked with Christian, Challen, and Eve. Thank you so much for your support and sharing your time and data with us. We appreciate it. We also want to thank the MSBA staff. They have been instrumental in opening doors in our professional career. Thank you for your knowledge and experience, sharing that with us. I'm going to give a brief background on the company and then pass it off to Alan, who's going to highlight the data and tools that we covered this year. And he'll also give you a summary of the project. Then Scott is going to give us a demonstration on our solver model, and I will wrap it up with our project challenges and recommendations. So in phase 1 of the program, we conducted a business understanding. Westwood Shipping Lines is an independent vessel operator that is owned by Swire Shipping. They are headquartered out of Puyallup, Washington. They transport forestry products, bulk project cargo, and containerized goods between Pacific Northwest and North Asia. They currently call 15 ports on 2 service routes. One is a 56-day service route, and the second is a 42-day fixed service route. Tanaya has been passing out some information with more details about the cargo, the routes, and the vessels. Because there's so much good information, we just don't have time to share, so we're just going to let you explore that at your leisure. It currently takes operation personnel several weeks to calculate the optimal routes, given all of the input variables and the output scenarios. So they gave us the opportunity to explore some of their data to determine if we could come up with a predictive tool, or a methodology to expedite the current scheduling process. So I'm going to pass it over to Alan to talk about data and tools.
Thank you, Shannon, for sharing some information about Westwood shipping lines. But now let's talk about some data from during phase 2 and 3. So Westwood provided us 2 years of historical data in Excel format. So there was really 3 main categories of data. The first one was vessel voyage data route between each port. And the next one is cost for each port usage, vessel usage, fuel cost, and cargo cost. And lastly, we received, the last set of data was potential revenue for each type of cargo transported. So now let's talk about how we process this data. So after receiving the data from Westwood, we create a data dictionary to have a better understanding of each variable within our data set. And then we review and format the data so that it was more friendly for uploading to software. And then we worked with Westwood to have a better understanding of what data we should be focusing on so we can use that for our later on mentioned model. And then we clean our data. Very luckily, most of the data was already fairly clean, but one thing we had to do for our SQL database was we had to create a composite key so we can join each table together so for querying. And so after storing the data, we would then upload the data into software such as Tableau and Power BI to build analysis and understand our data so we can use it in our optimization model. So now let's talk about the tools. First one, as mentioned, was SQL. SQL is a database tool, and we use this to store all of our data in one spot. The next two are Tableau and Power BI. These are both very powerful visualization tools and with great data manipulation features. In phase 2, we used Tableau, but then we swapped to Power BI in phase 3 because that Westwood shipping lines mostly use Tableau, so we wanted to stick with what they were using. And then the next two they kind of go hand in hand, so Excel, we're all familiar with this spreadsheet tools, but we really want to dive deep into the Excel solver add-in, which is an optimization tool, and we'll talk more about that in a later slide. So to recap, right? So the problem that we're facing is that with the dynamic nature of the shipping industry it demands a high number of personnel hours to create a schedule. So our goal was to create a tool to calculate the times, to save some time spent on creating an optimal vessel schedule. The data we'll be using will be the 2-year historic voyage schedule data, and our solution will be an Excel solver optimization model. More on that with Scott.
Awesome, thank you. Before I start getting into it, I want to familiarize you with a couple terms that I might be using so I don't confuse everybody. First is call and bypass. Basically what that means is if I'm going to call, I'm going to go pull into the port. If I bypass, I'm going to skip the port completely. And the next two is TEUs and MTs. TEUs is a 20-foot equivalent. It is a cargo container. If you look in the background of the ship, you can kind of see the containers in the background. Those are representative of the TEUs. And also metric tons. There's another part of cargo size that we're going to use. So in the solver itself, I'm going to convert metric tons down to TEUs so we know how much they are going to be. And then there's the vessel capacities. When I talk about those, the 1650, 1909, 1972, and 2036, those are the different types of capacities. There's actually 7 ships. 4 of them are 2036, and the other 3 are the other 3. And that's the maximum TEUs that ships can hold. All right, so what is a solver? It is actually a high-level Excel add-in for it, and what it does is going to take one variable, and it's going to either optimize it by maximizing or minimizing it. We can minimize, you can either minimize cost or minimize time. We chose to maximize profit on ours. So that's how it is. And then we can choose it to use the dive pass, also to choose the ports and all that. So when I get into the solver, I'll show you the different sections of it. We're going to have it color-coded for you so you can see it easier. The green section is the variable sections that the Westwood can enter themselves. And those ones could be the ship capacity, like I talked about earlier, how much TEUs or MTs are at each port that they can be put into there, which ports they want to go to, and then the speed of the ship. Then we have the orange section. These are constraint sections and the variable inputs, or the variable for the solver to use. So the constraints are the ones that keep the solver from going out above what it can be. So like it has a maximum ship capacity. If it has a maximum ship capacity of 1650, it's not going to go over that. It also has variables in there that they're going to go through all the calculations with. So if there's available of like 700 TEUs available at a port, it can run from 0 all the way to 700 and put any number in between those to actually do the calculations on those. And also there's also the binary ones that says it's going to be ship or pass. And that's a very important one because it's binary. It's going to be 1 or 0. And this is what it's going to happen to be when they do the calculations. If it's a 0 when we bypass it, it'll zero all those out so they won't be calculated in the profits or the cost. And if it's 1, it'll be times it by 1, and all those will be actually added into that. So next slide. And then we have the gray section, the calculation sections. There's about 100 and some calculations in there. So they also have all the cost calculations. So we have all the port costs, transfer cost, loading cost, discharge cost, and then fuel cost. In order to get fuel cost, we also have to, the solver has to say what port to what port it's going to. Then it has to decide what the distance is. And then it has to decide how much of that distance is an ecological zone and which is not, because there's different fuel types for each type. And then it's going to tell you how much fuel is going to be used. And then it'll get to the fuel cost itself. So there's a lot of calculations going on through this entire solver. And lastly, it'll solve for profit, which, next slide, is our main variable that we wanted to optimize. So if it's going to be profitable or not to go into that port, or if it's going to be better to bypass it. All right, so I'm going to do a quick demonstration of this. All right, so this is the input page that you first see on when we go into the solver. It's not the actual solver itself, but it made it easier for them to just put input in and then be able to see the results instead of having to decipher the solver itself. First, you can go up here and we can choose all the ship's capacity that you can put in there. So we can do the 1650, so that means 1,650 TEUs can be loaded onto that ship. And next, we have all the green section. So if you look at the top of the green section, you can add up into what port you go to. So they can do from anywhere from 2 to 12 ports. And then we also can put an end in there if they just want to skip a port. So it automatically skips it. So we put in like a variable and that it costs like $2 million to pull into that port, so it automatically will not go to that port. And then you can add up all the TEUs or MTs into the green sections that can be discharged at any port or loaded at the port. And then at the bottom of the green is the speed of each vessel. So you can choose what speed it's going through to see, calculate the cost at the end. And once that is all entered in there, you just go to the original page, go to data, and you hit solver. And when that comes up, you'll see all of the constraints that are in there. You can see which variable you want to maximize and minimize, and then all the variable cells. We'll hit solve, but I'm not going to because of the sake of time. We've already did that. And you can go back to input page, and then you can see in the blue section, right under the green, it tells you all the ports. It says call or bypass. And then right below that, you have a profit. They give you see the profit. And then it sells, and then it gives you a breakdown of all the cost and the profits at the bottom of that. So I'm going to turn it back over to Shannon.
Thank you, Scott. So we're going to briefly go over some of the project challenges. Most of us were new to the shipping world, so it took a while to digest the terminology and concepts specific to the industry. We also realized in phase 3, when we were creating the solver model, that we could have benefited from a more thorough data understanding in phase 2, specifically costs and their comprehensive inclusions.
It took a hot minute to build our relational database. We had several different Excel files that we needed to build together into our relational database, but we made it happen. And then when it came time to Solver itself, it's a very powerful but complex tool, and we're still learning how to troubleshoot. And the scope of the project proved greater than anticipated. However, we were still able to include the most important variables and parameters in the model that we will deploy to Westwood. For recommendations, we recommend that Westwood, once they have the model deployed, continually compare the metrics, specifically costs, revenues, and profits, with those that were projected by the solver model to gauge its accuracy. And we also recommend that they centralize records of historic delays and any pertinent data that's associated with those for future predictive modeling. We also are really interested in pursuing, well, maybe not us, but a future MSBA cohort, some bunker consumption and a predictive fuel. We kind of got started on that, but would like to maybe punt it to next year's group, possibly. On behalf of Team 11, thank you for joining us. Are there any questions?
Okay, and for our last presentation today, we have our Analytics Innovation Club.
I can take that.
You want to take that?
Yeah.
There you go.
Thank you.
You guys are all set.
Oh, you get the clicker? You want to use the clicker?
Go ahead.
Oh. Please.
All right, everybody, last presentation for the day. Thank you for your patience. And I'm going to start with first just the gratitude. So thank you, CBA, for even giving us this opportunity of having the AI Club and these projects and events and setting it up for us. I know we've spent numerous hours with Professor Turek discussing what can be done. We're stuck, we need help. And then a zillion hours with Osge sitting on, okay, my MacBook's not working, my system's not working, I can't access these things. So thank you so much for being there for us and pushing us towards getting more out of this course. I'm going to introduce you all to the AI Club the way we started. When we started off, it was Brandon presiding over the club, and he laid down this roadmap for what are the things we can do throughout the year. And he actually got the ball rolling for all of us, and we wouldn't be here if he had not planned it that way. So thank you, Brandon, for getting things started. And we have Kylie, who is in charge of communications and also the secretary, and Khadi, who is the treasurer. So that was the leadership for AI Club, and this is how we planned it. We had planned some SQL gaming competitions. We had planned some skill development to work on web scraping. We had meet and greet where we could interact with club members. We had about 30 people participating in the club. We also had some networking events. Thanks to CBA again, we had the opportunity to attend Informs. And then we had 2 projects this year for the AI Club, which we will walk you through when we go ahead. So these are some of the posters of the events that we conducted at the beginning of the year. Not the beginning, actually, when we actually got a grip on what to do with the AI Club, rather. So we had SQL murder mystery. We had an info session with tech recruiters. We had a web scraping event, which was very insightful. And then we went on with the projects that we did this year. So the two projects we had this year was first with Tacoma Pierce County Chamber and the second with Pacific County EDC. These are the amazing people we got to work with, fantastic feedbacks that we got with our client presentations. Unfortunately, they're not here with us, but I can assure you the feedbacks were great. So talking about the agenda for today's presentation here on, I'll be giving you a project overview. And then Kristen will take over the Tacoma Pierce County Chamber project details, and Brandon will talk about the Pacific County project details, and Chaitanya will walk you through the tableau we created for Pacific County. On an overview, Tacoma Chamber was about using their current CRM system, which they want to improve. Yeah, stop it there, thank you. Which they want to improve because they're not satisfied with the functionalities of their software right now. And when it comes to the other project, Pacific County, they have like a property database. That's just a bird's eye view, and we'll dive into the depth now. Kristen? Thank you.
So Tacoma Pierce County Chamber of Commerce came to us with a problem. They have a current CRM system, and they have their external grant tracking. Grants are a huge proportion of the services that they provide to businesses in the South Puget Sound area. And their grant database that they've built out in Excel was not integrated with any of their systems, and their grantees were not integrated in their membership services managed through their CRM. So we were tasked with finding a way to integrate these systems and make them overall better communicate and work with one another. Going into the project, we were told that they did want to stick with Chamber Master. They did not want to stick with Excel. Take a moment, mourn that, move forward. But they do need something that's improved and will allow them to manage both budgets and their documentation, both restricted documentation with employment and identity information, as well as their publicly reporting information about their grants and their progress on grant projects. Next slide. Next. Their existing CRM system is called Chamber Master. It is designed to work for Chamber of Commerce and focuses heavily on formal members of the Chamber. It contains information for receipts and billing transactions that communicate with their accounting software. Next. It also provides a single service to email all members or companies that are part of the Chamber database to send communications and notify individuals of possible grant and service opportunities in their region. However, the project relied on the fact that not all members fit the member profile. The email system was subpar. That the receipts, because they worked with an invoice system for the Chamber's actual funds, could not contain grantee information. And this information cannot be exported easily or imported easily for them to maintain any kind of grantee database. Our task for this project was to look at what inborn tools could be used within the current system that would allow them to leverage what they had and make their systems talk to one another a little bit better. However, after doing in-depth analysis and finding the basic function of the CRM, which is to email and communicate out to members, was the least performing option out of all of these, and working with our clients and doing in-depth testing of all of the functionality that we could in a live system, we moved forward with a recommendation that maybe Chamber Master is not where they should go. It is not meeting their needs, and it is not even performing the basic function a CRM should, which is communication management. Move forward. So now the challenges we worked on. This was a late start project. Oh, you can go to the next slide. Yep. Late start project, not enough time. We had multiple systems that we were looking at. None of them talked to one another, and all of them had their distinct problems. And we had limited ability to work with the primary system we were initially considering, which was the CRM system. There was no sandbox. Anything we did, we could not save out, we could not test, and we could not report out of. So we had to do all of our testing of all functionality in a live system without impacting operations for Chamber of Commerce. And with that, I'm going to hand it back over to Pooja for our recommendations.
Thank you. So we concluded at this point that suggestions on their existing CRM was not the right route to go. So we decided to sit with Michelle from the team and just find out what are the things that you're actually looking for and how can we help you find an alternate? So on the top right corner that you see, we are the criteria we kind of asked them questions on, which was based on budget, scalability, integration, accessibility, and usability. And here what you see is their answers for all of these criteria. We figured that they were looking for something which was cloud-based so that they can access inputs from anywhere in the field. They had a budget of an approximate margin that they had shared with us. They wanted integration with other products like QuickBooks and DocuSign that they were using. They also wanted user access to be a multi-user login because different people were using different aspects of the product in the CRM. And the most important part was we couldn't negotiate a lot with the options we had because there was a lot of uncertainty. There were times where they thought they would have just one project in the year and ended up having more than 6 projects. So based on that, we kind of ran through a couple of options that we found online. These were a list of services that provided grant management and tracking to a lot of organizations across the West Coast. So we kind of gave them these options and looked into which is the right match for what they were looking for. And we went ahead with Submittable. Submittable was this concise place which seamlessly integrates everything right from application to review and reporting. And it had these features of integrating with DocuSign. It had creating forms, and these were exactly the problems our client was facing. So we ended up giving them this result as a research analysis that we performed, and they were really happy with it. So I guess the next team that comes up is going to take this forward from where we ended, and it's going to be a continued project. But that was about Tacoma Chamber, and now I'm going to pass it to Brandon for Pacific County.
Thank you, Pooja. So this second project is actually really cool. It deals with some data that our classes really haven't taught or gone over too much, is with the geospatial information. So when you're dealing with a county that's trying to look at parcel data, you're going to be looking at like households or locations. Are they vacant? Are they derelict? You want to understand what's going on in the area. So with this information, they previously had a team actually build an ArcGIS map online, and it used the data that we're using today. The problem is that when that student team left, your access to ArcGIS also left. So they lost the entirety of that project that was previously done. So that basically means that they would have to purchase a very expensive software to be able to even replicate what they did previously. But I think by the end of this, you're going to see that we supplied something that may even be better than what they previously had, and they'll have it on hand. So let's go next. So the one thing that we wanted to do is, Alan and I, we would have conversations with their team back and forth, trying to understand, at the end of the day, what are you really trying to look for? We're trying to look between the lines and be like, hey, what can we provide you that will work? So we looked at the difficulties of the data. It's all in Excel, but it is working with geospatial information. And we can go next, actually. And so we started diving into a few different ways that this data set could be used or utilized. So ArcGIS does have a cost. QGIS is free use. This is a lot like R. You can download R and you can put it on your computer. There is no cost. QGIS is the same, but to the level of what we thought we could provide to them, we think another tool that we've been doing in our coursework would be much better. So we started looking at Power BI and Tableau. As a student, mapping information is not really the best through Power BI. There's a lot of limitations that you have to get a separate download. You have to do different items to be able to get mapping to work. Tableau on hand, though, is beautiful. What we were able to create was jaw-dropping, and I would like to pass it off to the king of the Tableau for him to demonstrate what he created.
Thanks, Brendan. So as Brendan has explained, so the client has most of the data in Excel sheets. So there's nothing much you can do with the Excel sheet because if you have it in the data, you can't visualize what's happening in that particular area. So what we have currently done is that we identified the certain KPIs, which might be useful for the client. So as you can see, we identify the total properties, sewer count, vacant properties, average price, private properties as certain important KPIs for them. And along with those KPIs, we identify certain important features as well, like the city-wise, property-wise. So all these graphs, what you are seeing on the left-hand side, those are interactable. So you can click on one graph, and on the right-hand side, the map automatically changes, and the key KPIs will automatically change as well. So at the bottom, we have included pricing as well. So we divided the pricing into 5 different categories, like 0 to 200K, and like 5 categories, and the last one being above 1 million. So most of the housing are more than 1 million, and the second most is 0 to 200K. So on the right-hand side, you can see all those location details, and this is what we have created for them. And you can see the map doesn't really give much details, is it? So what can we do to them so that it will be more interactive for them? So what can we do to them so that they can do more with the maps? But the Tableau which offers is that only this aerial view of this particular map. So we had an idea. So in general, whenever we have an address, so what do? We take that address, we keep it in the Google Maps, and we find out where it is, and we'll search the neighborhoods. So we had an idea, what if we can integrate Google Maps with Tableau dashboard? So that's what we have done. So we have integrated Google Maps with the Tableau dashboard, not only Google Maps, the street view, and the satellite view as well. So when you click on one particular place, when you see on the bottom right-hand image, you can see the satellite view of that particular image. But not only that particular location, you can check the neighborhood locations as well. Even though we don't have that information in our Excel sheet, you can see the other places which surrounded by that particular location. And also, if you want to see the images of that particular location, you can do it via street maps as well, which you can see on the top. So this is how we have integrated Google Maps with their dashboard. So I guess this information will be helpful for them, and it will make them to take better decisions in future. Thank you.
Great job, AI Club. Thank you very much. Okay, so we are almost complete. I won't take up too much more of your time. Okay. All right, thank you. Okay, but I would be remiss if I didn't point out at this point, we are seeking applied project proposals for next year. So for anyone in room or anyone watching on the live stream, we would love to hear about any project idea that you have for our students to continue on for our new batch of students coming in June, to share an experience and work through a project similarly to what you saw today. So I would invite you, if you have any, just even an idea in your organization of maybe a business problem that you have related to data in your organization, or maybe you're interested in seeing how the data you have might relate to solving the business problem. Any idea whatsoever, no, to me, I live by the mindset of no idea is a bad idea. So I would love to discuss that with you. So please feel free to reach out to me. My email is turikmd@uw.edu. If you're viewing, this is probably going to be more helpful on the recording. Here is the URL to our website, and we will also have links available. So thank you very much, everyone, for attending. Thank you so much for all of your support for our student teams. And to our student teams, this is I would say, the first big congratulations that's going to be coming within the next few weeks here. So excellent job, everyone. You have a lot to be proud of, and thank you very much. Oh, and don't forget, we do have our poster session. Please come back and join us at 2 o'clock if you're able. We will have the poster set up. You'll have a chance to actually interact and discuss the team's projects with the group. So thank you again.